The i14y Lab. How did it start and why? Well, we talked to Andreas Gladisch, consortium lead, to find out.
To take Open RAN from an idea to a product, a new way of testing cooperation was needed. We launched the i14y Lab in 2021, together with a consortium of strong partners and public funding from the BMDS. The goal was clear: build an open, collaborative space where vendors, operators and the ecosystem could cooperate to deal with the many new test scenarios the openness of Open RAN brings.
So we put lots of effort into our automation of our i14y Lab in order to improve the testing, making it much faster and provide in that direction the best and most valuable efforts towards the ecosystem and the community.
Europe needs an open lab that offers reliable and reproducible testing and serves as a strong European anchor point in the international ecosystem. i14y Lab is just the first step to bring Open RAN into life. And it's the first step of a vibrant European ecosystem.
Well, hello everyone. Hi, dear guests, dear speakers. Welcome. Welcome on behalf of the i14y Lab. I would like to welcome you all to our 2025 Lab Summit. My name is Marina and I will accompany you on your summit journey. And also, please have a warm applause for my co-host Andreas today.
Yeah, so indeed, welcome also from my side and on behalf of the entire consortium, I have to say, because i14y Lab is a joint effort of a complete consortium. And I guess you know that already because it's number 4 now, i14y Summit number 4. And hope you get the opportunity to learn what we have achieved, to see where the community stands. And before I talk too much, back to you.
Thank you, Andreas. As Andreas just said, we have 4 exciting years behind us, building and developing the i14y Lab and contributing to the Open RAN ecosystem. And today, ahead of us are panels, keynotes, dedicated breakout sessions about the future of Open RAN to topics of certification, openness, and ecosystem. First, we would like to give you an overview of what to expect on today's agenda. We start with the first block, with a focus on innovation, Open RAN in business, tech, and also the policy perspective, asking what lies ahead of us. Followed by the second block about how to establish consistent and repeatable testing, and of course also about the challenges and the way forward in this matter. Finally, the third block will deal with the future of open source in Open RAN and also AI in Open RAN. Of course, we have to deal also with this subject. Last but not least, we will have an outlook on i14y Lab and its future. And of course, we will also have a longer lunch break and some shorter coffee breaks where you have plenty of time to mingle, network, and also visit our marketplaces. One more remark, don't forget to sign up for the breakout sessions to enjoy our interactive deep dive sessions. And Andreas, maybe you would like to have some closer view at it and introduce us to it.
Yeah, so first of all, why is that on the agenda? And it seems to be new here. So first time we try to go for interactive sessions. Forgive me that I skipped the interactive deep dive session. That's a little bit. So interactive sessions. Last year we sent out a kind of survey. So we try to understand what are the expectations from the community. What would be the most interesting approach to help you with discussions and with networking and even make progress concerning some topics. And the idea was, or the feedback was, we need more time for discussions. We need more time in smaller groups. So proposal is, and thanks to Katja, by the way, the proposal is to go for this interactive sessions. And here is also the proposal of the topic. So we would like to talk about the applications for verticals. Some of you may have attended yesterday the discussion. These verticals are very important for for the overall ecosystem. And it's the pleasure to find moderator Stefan Terral to run the session. And yeah, so we'll see later what the result will be. Second session, energy efficiency. Always a topic. Number 2, Jan from BISDN will be the moderator. They're accelerating Open RAN innovation, Open RU innovations, number 3. And number 4 is SMO RIC ecosystem. That seems to be an improving topic or an evolving topic now. Number 3 is joint activity with OCP. You may have noticed that there is an activity at OCP on ORU development, and the last one is a joint activity with TIP. So please think about which would be the priority. I think it's difficult to make a decision. At least for me, it would be difficult. So please check which one you want to attend, and then there are the options to register, and later you'll see the places where we meet. No, it's already listed here. Main stage, 5th floor, main stage, 5th floor. That means we split the sessions, and depending on what you want to do, be there or be at the other place. So that's quite easy.
You will find it. Just follow the sign.
It's not that difficult.
It's not that complicated. But also one last housekeeping and informational remark about our guided tours. Of course, do not forget to sign up for these as well. Andreas?
Yeah, again, so i14y is a joint effort. It's a consortium, and luckily we are at a place of one of our partners, and another partner is not far away, or the partner lab is not far away. That's why we offer a guided tour to ENTC lab and a guided tour, a little bit more research-oriented, to the HHI and what they have done in the context of i14y. So, and the meeting point, I should mention the meeting point. So one is outside at the main entrance, and the other thing is over there. There's someone waiting for you if you want to join the HHI tour. So back to you.
One of us, thank you. Every one of us will guide you, so no worries there. So thank you for the insight of what to expect today. I'm looking very much forward to a very interesting, exciting, and insightful day with you. Yes, thank you, Andreas.
Pleasure.
Well, an applause. Applause for Andreas, for my co-host. You will see him again, be sure. And now we are starting with a deeper dive into the Open RAN universe. I'm especially looking forward to the outlook on how policies and industry together can make Open RAN successful. Please welcome on stage for our first keynote, Dr. Kim Larsen, with the update on the techno-economical state of the industry. Kim, the stage is yours. Thank you.
Let's start with, I don't have a timer here, I had that yesterday, so that's too far away. Oh, okay. Oh, there. Well, I mean, you know, men at my age, let's not go further. So I have I was asked to give a sort of kind of opening of where are we with Open RAN. Where are we with Open RAN? Thank you so much. And another thing here. And I told Katja and Andreas and others, well, I've not always been a fan of Open RAN, many of the aspects of that. So are you really sure? And they said, yeah, Kim, don't just do it. So if anybody afterward wants to blame anybody, blame Katja. But to be honest, I am not going to, of course, trash Open RAN, because it's something that I've been part of since 2018, when we initially started out in XRAN, and then 2016, XRAN. Later on, we got merged with ORAN, and the rest is history, right? So let me start with this one very quickly. One of the themes over the last 10 years, or maybe even longer, has been disaggregation. I don't think you can open any LinkedIn page, go to any conference without hearing people talk about disaggregation. Let's pull things apart as much as we can because we can, and just let's do it. And it's almost been a religious mantra. One of my good friends, when I told him I was coming here, you're going to this religious sect forum and talk about your religion about disaggregation Open RAN. And I said, no, I think that's maybe going too far, because from the last 2 days, I've actually seen that most of us are actually skeptical but optimistic. There are things that we like and there are things that we don't like. And you know what? Isn't that always the case with technology? I do think personally that we have gone a bit too far on disaggregation. I think there are things that make total sense. Disaggregating hardware and software, that makes good sense. If you have two entities in a system where they scale very differently, taking these two apart and working on them separately makes good sense. I also do think that there is a cultural aspect of pulling things apart. And if you look into this, it's an area of interest that I've been digging into quite a lot lately as I'm getting older, is that if you look at Open RAN and a lot of the topics we discuss here, it really came out of the brains of a Germanic-centric engineering culture, Asian-centric in terms of Japan and South Korea. And what are they great for? They're great of best of all breeds. We want very narrow focus and dedication to components and make the best, and then we integrate them and we have the best of the best system we can possibly get. I'm from Denmark, so I'm part of that culture, if anybody would think I'm now standing there and pointing fingers. I pointed at myself too, and I have been part of this journey. But it's something that is good to reflect on, that as you are an opinion maker, which Deutsche Telekom and Germany and South Korea and Japan are in this field, you also take your cultural baggage with you as you go into the R&D, develop it, and ultimately also operate it. So this is a word of caution. What was the promises here? We wanted freedom of choice. We thought we paid too much to our suppliers, and we wanted to break it up or break them up, so we were actually able to pay less. And of course, you could say RAN is a multiplier, because we have so many of these. It don't need to be very expensive in order for making the total very expensive, very costly. And typically for the mobile industry, 60% of our capital investment has gone into RAN. If you look at the technology OPEX, it's probably about 50-60% as well of that goes into the RAN. So it is a very costly thing, and if you can reduce the CAPEX for this, isn't that a great goal? I also think there was a worry of being locked into a supplier, although I would be cynical in saying that we have all done that open-heartedly as soon as that supplier gave us the right pricing we liked, which were a lot lower than maybe European alternatives. But let's not go into that debate here, which is a bit interesting in Germany in particular, and Spain, I guess. Intelligence at scale. We all in the time of 1618 had this idea that we certainly needed more intelligence. At that time, we talked about data science, machine learning, clever statistical tools to understand better what was happening in our networks, to try to get a handle on complexity. Billions of data points were generated over a day, and very little of that was used. It was, by the way, also the time when we believed that we could monetize big data. I don't think any of us has been terribly successful in that, and we often forgot, well, all that data, maybe we can use this ourselves to actually become more efficient, smarter, and intelligent in the way we actually operate our networks. So intelligence at scale was and became a very important point, and I think that is particular something that we need to keep in the back of our mind, and still might actually make this whole journey we have done over the last almost 10 years worthwhile. Of course, we all realize that maybe short term, maybe not the most economical, smart way what we were going to do, but maybe we believe over long term that this also could be a cost-efficient solution. I do want to make the claim that in general, when you split up systems and architectures, you do not become more economically efficient because you create more interfaces. And simply what you say by splitting up, you actually pay back in interfaces. But if you add a decimal dimension to this, you may end up with something that is very sensible and also economically sound. And that's, of course, what we believe will happen. I think we shouldn't kid ourselves, and I think that's already clear from my start. ORAN is not an exercise of simplicity. We haven't made things simpler by going down this road, because we want the best of breed. We want every single element in this chain of our architecture to be the best. And we break up interfaces that before were maybe not that open, but did honestly worked, as far as we know at least, because we look into them, but a different point. So don't kid yourself. By the way, often the rigs, the RAN intelligent controllers are sort of highlighted as something that's fantastically innovative and actually something that came as we integrated XRAN with ORAN. Mind you, XRAN was very much about just splitting up the CPA interface between the RU and the base station and the RU, the base band unit and the RU, sorry to be totally accurate. The intelligence and having a mean of supporting intelligence in the network came out of the self-optimized network architecture that also actually at that time was just being standardized by 3GPP for 4G, having an offline element and having an online element. Mind you, this was not a box. It was a set of functions. And that was then taken over by ORAN and basically made into architectural entities, and at least one of them is actually a box, and the other one normally is seen as being embedded into the SMO, the service manager and orchestration that we have in the ORAN, which I didn't put here. So very clearly, if you look at simplicity, you couldn't get it more simple than the left side, and actually, as we moved on, we've broken up this and made it in generally more complex. Alas, of course, the rig is a new architectural element that we have added to this, but it doesn't make it simpler. Quite the opposite. Right, so can we learn from IT? And of course, the answer is, even if probably most of us are network folks, we say, no, we don't look to this side. They don't know what network is, and they don't have any idea about quality. They're software people, and we don't like software people because, again, this is sort of a bit flossy and artistic. And of course, that's not true at all, because we really like software, because if we want to get this to work, we actually need to get our S together when it comes to developing software, probably much more than hardware, because that's something we generally do understand. So can we learn from IT? And I think most of us have been in the industry and operators, we were used to huge, complex IT projects that took money away from our networks because it just could not get it to work. And every time they made a small change, it was another 100 million that you had to post into this. And often a lot of that are custom made and lots of different suppliers, and were difficult to handle and never probably worked as well as we thought it would. By the way, that's for me is a key example of best in breed. You take the best of what you can find out there, you put it together, you use huge amount of CapEx and development and people effort to integrate this to something that hopefully works a bit like what you had intended. And I'm not saying that this is like ORAN. This is more complex than ORAN, and certainly we helped it in being much more complex than ORAN. Where are we today in IT? I think most operators are actually going towards best of suit, which is sort of the right side, where instead of trying to integrate multiple boxes at each on an individual level, maybe the best you can buy for money, this is just so huge and complex to deal with for an operator. And yes, if you are a Telefonica and a Vodafone or a Deutsche Telekom and you have massive amount of people in your organization that are fairly young, you can of course throw them at this problem. But most of us are not in that privileged situation any longer. I mean, most of us in our industry is 50 plus, right? And, well, we don't have the stamina to work on this. So what are operators doing in many places of the world is actually going towards best of suit, and this is actually what you see here. And they are discovering, no surprise, that actually operationally makes life a hell of a lot easier. What a surprise. What a surprise, right? And it also, it's just less cost. And yes, they do get to some extent stuck with a supplier or a solution integrator, but that's nowhere near the lock-in they had from their best-of-breed solution. And if you look at the total cost of ownership and not just what you invest up front, and the uncertainty and risk you have with going the traditional way of IT, that actually is something that most operators today embrace. And it doesn't necessarily mean that every single box or architectural entity is from the same supplier, but it means I have one supplier that provides me a solution. They have worked with open interfaces. They make sure that that whole stack actually works. And I only have one to blame, not 10 or 15. I mean, this is crazy, right? Most of our network people say what happened in IT in the 10s was just amazing. We look at all the money we pumped into this to actually change it again because it didn't work. It's an interesting story. Now, how much money is there in this? What is the money? I've done a lot, and you can find that also online on looking at CapEx spend, revenue over since the very beginning of our mobile industry, or telecom industry, which I say the beginning is pretty much for GSM. Sorry for some of the older folks that was used to fixed before 90s, but for me that's the beginning. Certainly beginning of spending a lot of CapEx, a lot of money into this. There has been highs. We spend a lot of money around 3G, UMTS. This is just including the active CapEx. It's just really the RAN. It's not building sites. It's not passive building the infrastructure, because that's a whole different story, although it actually does follow a bit this trend. But what you see is that it was high. 4G, we started introducing lots of different frequencies, went from just having 900, 1800 to having 800, 2300, 2500, whatever. Massive, not massive, but we started doing MIMO deployments, etc. So some of that it reflected there. And actually, people say, oh, 5G, it's enormous. But the fact of the matter is, it's actually not really where we spend most of the money. Of course, in Germany, if you are on mobile, you probably suffer a bit from the society's focus is to build out fiber. And if you look at Germany's state of fiber deployment, it is a laggard in Europe. And it probably will take another 10, 15, 20 years before you're there on fiber, right? So there is a lot of reasons for why more money goes into fiber than maybe initially we would have liked if we were in the mobile part. So just saying here that, yes, there's money in this, but it actually, well, I would like to have just 10% of this, 1% of this, but it is not the same as a total capital spent in the mobile industry as such. So, again, from this point, can we learn from IT? I think there are many learnings. We can learn both what we shouldn't do and obviously what we should do. And I think there are a lot of interesting developments in TM Forum on openness and structure of processes and that are very worth embracing and looking at also for network people. Again, there's lots of text on this, and I would say don't focus too much on this. The whole idea is that we had a period, and again, it's a period where we were very, I think, naive, like we often are in the infancy and as children, starting to learn something new, that we could break everything up and we could just go out and choose any vendor we wanted and mix it together. This is quite an extreme view, right? I mean, if you're a greenfield, you might try to do something like that. But if you're a sensible operator with millions of customers, I don't think you would be crazy enough. I hope you wouldn't be crazy enough to pursue the middle one. But that was what we discussed. And that's what I think Andreas and many labs around the world are facing. It is to try to test all these different choices and how you put things together. And of course, this is a simplification. Start looking at all the interfaces we have in here, and then the combinations of interfaces with combinations of suppliers. And if you do that math, which I actually have in this presentation, but was not allowed to show because of time, and I understand the time aspect. So, yes, we are going towards the right side, maybe not as extreme as you see here, Although if you talk to the people on the ground, you have a bit of feeling that we're moving towards here. So, can we reframe ORAN? And should we do? Well, first of all, my message to you is we should do that because it respects the people that we have working for us trying to get this to work. It is not an open for all, full plug and play fest, ORAN. It just cannot be. It makes absolutely no sense for a credible operator with millions of customers to pursue this. They will go into the same trap as we had with IT and best of breed. Best of suit, or as close to best of suit, is my recommendation. AI RAN, or AI in RAN, or AI on RAN, or whatever permutation you would like, is required. We have to work much more dedicated to include intelligence in an open and honest and flexible and ethical way in our systems. And there are a lot of policies around this because this goes into our critical infrastructure. But we need to do it, and we need to think about it. And again, we have to do it intelligently, because of course you can put AI everywhere. That's not really the challenge, but we have to do it in a sensible way, in an intelligent way. Just because you can do something does not always mean you should do it. And then finally, which is a bit of the first one, well, we think about AI, automation, and scale. I do believe that it will bring down the cost of ORAN. Maybe not even long term, which is, somewhere out 20 years from now, or in 6G maybe, but probably more medium term than what we are currently seeing. So I still have 38 seconds, and I think that's without question. So I want to make a prediction. I think the rigs will go away. I think that learning from IT, the rigs we have today, in particular the standalone, will disappear, and you will have an API-based RAN architecture similar to what we today also talk in many aspects of IT. So with that, thank you so much.
Thank you so much, Kim.
You're
Thank you for learning a lot about promises and maybe
Good.
yeah. Thank
Time for
you.
questions,
And
or?
it's do we have time for questions? Or no, I think we're going to deal with the questions while the conversational part of the task. And now, please have a warm applause for Maya. I would like to welcome on stage Maya, who is the CEO of the Open RAN Alliance.
Well, good morning. And first of all, I'm 50 plus, so my memory is a bit reduced. That's why I have my favorite toy here, my laptop. I also would love to say a big thank you to Katja and to Andreas for inviting me and sharing their own Alliance view on this journey. And though my speech will be quite different to Kim's, probably the results might be quite similar, which is interesting, right? So let me briefly introduce myself. I'm actually Maya. I'm joined the ORAN Alliance in the beginning of the year as a COO. And in contrast to most of you, my telco or my deep tech know-how is quite limited. Why is it worthwhile that I'm standing here nevertheless? Well, I started actually my career in procurement, in tech and IT procurement. See, that's where the similarity starts. Actually with a very large system integrator, yeah. I moved then to major operators where I helped to build highly profitable broadband and video business with much higher margins than the mobile area. Well, later I joined the technology division, and my core skill is actually to do large transformations of organizations, hopefully also of industries. Let's see. Heading large transformation, merging networks after acquisitions, integrating critical systems, and aligning large engineering team to deliver strategy, not specifications. Well, then I had actually the chance to work in startups. I headed one startup with a scope on virtual networks, and another one I just did a journey to the IT area, where I focused very much on IT development, but also on AI over the last few years. So this actually gave me a much closer look into product development. And that's why it's important, and why that's important I will show you later. So while I don't have a deep technical view as most of you, I can offer some useful ideas, and I'm very happy to also listen to yours. So my role as a COO of the ORAN Alliance is not to lobby, not to push political agendas. My role is really to focus on ORAN Alliance and our member ideas and vision, which is not always the same thing, which is important to consider. Yeah. For us, Open RAN not only has been a technology, it has been a movement. We have seen here some decades and with a different major aspect we looked at. So, and it's far beyond technical puzzles. Very much a similarity to the modular approach. So it's about solving structural and organizational challenges as well. Yeah, governments and policymakers may draw their own conclusions from our technical work that's happening, but the ORAN Alliance remains focused on engineering and implementations. And this is also the scope of this summit here, right? Implementation. How do we get there? So, if we move and look what has been our journey so far, it has been a tough one. Yeah, when the ORAN started, it was 7 years ago, actually, the ORAN Alliance was founded. It was not a finished system, it was actually a black box. It was a vision we had as an ORAN Alliance, being founded by 5 totally different operators throughout the world. And a belief that radio access network could be more open, intelligent, and more interoperable. Yeah? It doesn't mean it needs to be scattered. This journey hasn't anything but easy. Yeah? If you have a look at the guy or the girl, it's a tough one, right? We knew what the direction would be or should be. Even though the climb in the picture may look like a single person, it's not. It's made out of team effort and the work together of really totally different cultural backgrounds. So that's what brought the ORAN Alliance here today. Where do we stand right now? Well, it's not always an upward climb, and right now, quite some of you, organizations, the operators, vendors, also the academics, we sometimes feel that we are not plateau right now. Yeah. Someone actually said here yesterday, well, it feels a bit like there's one foot on the brake. How can we change that? Well, progress is there, but acceleration not. So this makes the movement even more important, and that we keep all pushing together. Not operators alone, not vendors alone. The key message is very simple. Open RAN is not longer about planning, we are now in the phase of execution. Yeah. I was asked to bring our technical details, which we are now looking at. Well, I actually brought them to you, so you might want to have a look at this. But this is actually what we are doing this year and next year. And you know the planning phases, right? So this is actually already history, though it's implemented in 26. Yeah? So maybe it's not worth to look too much into that, but to look into the future. Yeah? The critical point is actually that we not only have to look at the specification of standards, but we have to look into the products. Yeah? And that's what's at the end selling. It's not specification which are selling, it's products. And it's the products the vendors are producing and the operators have to buy. And that's where our ecosystem is not working yet perfectly fine, because everyone needs to earn money. And that's not happening yet. So, the hardest step, again, is that we cannot do it alone as operators. Vendors cannot do it alone. We must bring products to markets, and we really must deploy them, or the operators have to deploy them. And that's only then when Open RAN will move from promise to reality. So that's why with the bridge from specification, standard feature, product is a critical one here again. Well, and that's actually why we as the ORN Alliance are now looking into the future. Sorry for that one. So we actually started a survey a few months ago, and that includes actually not only operators, that's not only including vendors, and it's not a survey to produce headlines. It's really to understand our members. We are around 270 members right now. In the beginning, we were very much operator focused, and still there might be good reasons for looking into that, because that's the ones who are implementing. But if we are not understanding what our members, the vendors, are doing, we will not change the ecosystem jointly. So by actually approaching this survey, we are looking into 6 strategic areas which we think are relevant for the next years to make the ecosystem work. So that's certification and badging, and the i14y Lab Summit is a perfect example here, and we will hear much more about it. But it's also chipsets. Yeah, so the world is actually ruled by chipsets, not only in this industry, but also in other industries. And if we are a bit critical looking into our industries, our understanding of chipset is really very much reduced. We have the open source community. It was also mentioned the last 2 days. We also will have a session today. But what does it mean? What do we really have to do to make that fly? We have the system integration part. Also a very large one, because it's really like, how can we make it work, and getting away or removing the fear of the operators that it's not working, that is too complex. Yeah? And that's actually an area where we can earn, or where some people might earn money. But that's not a bad thing, because the job of system integration is a very tough one. Yeah? So maybe we want to look into that, and as mentioned before by Kim, so in the IT area, system integrators, you pay 100 million, and 2 years later you will have to pay the double price, but you're aware of that, yeah, and you take that into consideration. Yeah? Maybe we don't want to pay that amount, and maybe we want to be more successful with system integration, but nevertheless we have to pay for that. Mm-hmm. So then we have 6G and 3GPP alignment. For everyone here in the room, 6G is an important topic. It will take some years, but as 5G wasn't successful, nobody is really eager to do that. So maybe we also want to consider doing that differently. And that's very important for the ORN Alliance to look into the 6G approach. How will we really make that? Because that's the chance for Open RAN to be successful. If we don't take that chance, we can go back to the black box, right? For the ORN Alliance, we have been really much focused on standards or on specifications, how to design that. But if we are doing this in our own room, without speaking with other SDOs, without speaking to other organizations, we will only do specifications which might not be relevant. So that's why we are really very much looking into improving our relationship with other SDOs, with 3GPP, to ensure what we do is relevant also in the future. So speaking a lot about technical topic or system integration, in the end, it's a journey, as I mentioned. And a journey is about people, it's about organization. So that's why we also look, are we doing the right thing? How are we doing the things? How can we speak better with other organizations? And that's why we are very much critical looking into our organization. How can we improve? How can we become quicker? How can we become better? So this is actually our track map, identifying when support is needed and how really keep the execution on course. So what does it actually mean now? We are interviewing actually all our members, but we are also looking into other industries. How can we copy smart? How can we copy smart on chipsets? How can we copy smart on system integration? So you are all invited here to support our survey, and we are very happy to share it. And again, for us, it's really about designing the future, looking into another industry, into mobile phones, into the hardware. Apple is always meant or claimed to know what we want in the future. Yeah. So if I ask you, you might have an idea, but we also need to design it, probably with some crazy ideas. So what success looks like, I've mentioned what we will look into, but in the end, it's about Open RAN. And if we have 1,000 different products, or if we have modular systems, that's still open. Yeah, but what we all want here in this room is Open RAN. So let's get on the journey, try some crazy ideas jointly, and really make it happen. Thank you.
Thank you, Maya, for the insights. And well, now let's bring all the perspectives together. You can stay on stage, I think, because we are... yeah, we are bringing the perspectives together, as I already said, and then now I would like to join all of you to think about it, but also to participate in a way in a chat, in a conversation about how policy, technology, and business all come together to contribute to the Open RAN system. And it's a special, distinguished pleasure for me to welcome on stage Philipp Gröschel, Director Government Relations of Telefonica Germany. Just welcome, Philipp. And of course, Kim and Andreas, please come back on stage. Very much looking forward to this session and the policy perspective.
Okay, welcome again. Thank you very much for joining this little session. Now we want to build a little bit of bridge between, I would say, technological aspects of Open RAN to policy, because the next speaker we will receive or will we see here on the stage is Thomas Jatzombeck, the State Secretary of the German Federal Ministry of Digital Affairs, and we will receive a short keynote from him. And therefore, I think it's a good point of time to building a bridge between this technological discussion and what this means from a policy perspective. But before we start with this short discussion, I just want to introduce you to the round. So Maya, you have already introduced yourself in a very smart way. So I can make it short, I think. You're looking back on 20 years, on a 20 years career in the automotive, consulting and telecommunication sector. And since this year, you are the CEO of the Open RAN Alliance.
Yes, thank you.
And you studied business administrations and physical educations, which is sports science. And I asked you, why have you studied this nice combination? And you said, what I think it's very nice, it's a good combination of having an active mind and an active body. So this also stands, I think, a little bit for your mindset. I would assume that it is like this.
Yes, thank you.
So welcome again. Then I also want to reintroduce Kim. So you are looking back even on a, I would say, 24 years or even more than 24 years career in the telecommunication sectors. You have studied physics and mathematics, also made a PhD in mathematics, I think, physics. And yeah, you worked in a lot of different leadership roles in the telecommunications business, especially at Deutsche Telekom. Have been, for example, CTIO in different operating businesses of Deutsche Telekom all over Europe. So you're looking back on a very, very long career of leading technological organizations. And
I was young when I started.
yeah.
Really?
Yeah, and now you join here our conversation with a lot of experience, which is also very nice. And another very experienced person is Andreas Gladisch, who also is very long in the telecommunications sector. and studied communication studies, studied telecommunication technologies here in Berlin, I think. And currently you're in the role of the Vice President Emerging Technologies at Deutsche Telekom. And you are also leading the consortium of i14y. So you can say you are one of the parents of and facilitators of i14y. Very happy to have you here on stage.
Yeah, thank you.
And last but not least, I also want to introduce myself. I'm the youngster here because I'm only since about 10 years in the telecommunications sector. And I studied law, not technological things, so more like you, more the non-techie things. And I am currently leading the policy team of Telefonica Germany as Director Government Relations. So let's talk a little bit about the political or policy aspect of Open RAN. I want to start with a short question to Maya. So you already introduced a little bit the idea of the future of Open RAN, how it should be developed to also meet the needs of the market, the needs of the vendors and things like this. But what do you think, where do we currently stand in Europe in terms of development of implementation of Open RAN? Is the ecosystem and all we have done in Europe so far, is it enough to really kick off and scale Open RAN? Or what is your assessment about the current situation we have here in Europe?
Okay, well, thank you for raising this question. Well, first of all, we have been here, like we started, and ETSI actually started to adapting our specifications into standards. And now it's actually approached throughout the world in North America, Korea. We are also going to the India Mobile Congress and speaking there about it. But in Europe, I would say we are on a okay track. Yeah. So there's accelerating expected over the next 2 years by Deutsche Telekom, for example, 3,000 sites. You might know the numbers much better than I do. Vodafone is actually announcing that it's aiming 30% plus of their European sites, and they have also a good footprint over Europe. In Asia, it's Rakuten and NTT. So it's on a good way. I wouldn't say it's great. As we've mentioned before, it's probably more on a plateau, and certainly there's room for fantasy and for more.
Okay, thank you very much. This also covers my personal impression, and I think what is, from a policy perspective, always a challenge is that we have a very fragmented policy framework here in Europe. This means that different European member states are doing different things, different funding schemes, different research policies, and this makes it also sometimes not so easy from a company perspective also to participate in all these things, because so many different things are happening in Europe at the same time, but they are not always perfectly integrated or connected with each other. So this is also a challenge from my perspective. I just wanted to add. But now, because it's not about my perspective, it's about your perspective. Therefore, I also want to integrate Kim now in this little conversation and want to ask you whether you see also specific risks when policymakers intervene into network architectures, imposing requirements for the infrastructure, like, for example, diversity and things like this, from a more, I would say, policy way of thinking. And whether do you think that it could also be a risk for the industry and for the development of the technology? And do you think that it is really necessary to have an active role of policymakers in this discussion?
Wow, well, I think 3 questions. But my very easy answer is I don't see a risk. I think policymakers, politicians must provide guardrails for the industry in how to basically, what are the framework within they can operate. I think this is super essential, particularly as we discuss some of the more, let's say, intelligent ways of implementing AI into our hearts. So they must ensure that what we do has a minimum harm and a maximum benefit for society. So I think there's no doubt about that. Now, that's on policy and guardrails, which is very different from telling me how I should architect a particular system. I don't think I've ever really met a politician who's super interested in the underlying technical details of an architecture. It is really more on the policy level and the guardrails. And I think that's absolutely essential that they do, because I don't think we can leave that to engineers. which still is 80% male in just out of studies, and we all know that the prefrontal cortex is not very well developed with these people. Only when you get older, it gets a little bit better. So it is absolutely essential. But you know, Andreas and I, we had a meeting with a US private equity guy or investor guy some years ago in California, and he was begging Europe to come to US with how do we actually solve some of these policy-related questions in our technical environment, and how do we comply with it? How do we come up with solutions, innovation that comply with, let's say, more strict guidelines on privacy and, let's say, minimizing the risk of the critical infrastructure. So I think politicians and policymakers must provide guidelines, and not 2 or 3 years after a thing has hit the market, preferably more or less the right time. And I think that's the biggest challenge. AI is a good example. Satellites is a good example. I mean, why do we start talking about investing into satellites now? It's pretty much already. It's not too late, never too late, but it's timing is not great, and AI is another good example. So yes, they must.
So that's a nice invitation for Thomas Jatzenbeck, that policy framework and let's say working together with policymakers also is very important for us. Well, my personal impression is looking back on the last years is that the idea of disaggregation fits very well to the idea of geopolitical de-risking. And therefore, I always had the impression that Open RAN really fits to the mindset of policymakers in Europe at this point of time. But on the other hand, that's more my personal thinking, is that geopolitical de-risking does not necessarily means disaggregation. It also means more or less to set up own capabilities in Europe in the ecosystem, which must not necessarily be fully disaggregated. But this more or less my perspective on this discussion. And now I want also to integrate Andreas to our discussion. And yeah, as you are the, let's say, father of, or one of the fathers of the i14y lab.
The grandfather.
No. Let's say. Yeah, it's true. Yeah, I specifically, of course, want to know from you what role of test beds, projects like i14y, and public investments, public fundings. What role does this play for scaling up Open RAN in Europe? This investment of the state and the support of the state.
Yeah, so let me start from a slightly different angle. So if you apply for public funding, one important question is usually, is there a market failure? So that is what usually the politicians want to hear. So why should they do some public funding, some investment in certain projects? So that's, at least in some domains, this is a key question. And I think this is something we should keep in mind. The situation in beginning of 2020, etc., so some geopolitics, in summary, there might be something like a market failure. Okay, so that was a trigger point, the first one. And the second one is, yes, if we want to, somehow it's a transformation of the industry, what we try. So Maya mentioned that. So if we want to do that, there is no company in Europe that can do that alone. That's impossible. So we must find some constructs to do it jointly, and perhaps with the support of public funding. And for us, it was obvious that time, hey, yes, we disaggregate, we create these new interfaces, and there are pros and cons, but they make sense. If we want to see new players there, let's discuss later how that could happen or not. But it was obvious we need this interoperability, and we need a lab and a complex test infrastructure that costs a lot of money to run those tests. And the intention was to open it up to the public or to the ecosystem. So, and you see a couple of examples here in the round that smaller companies learned thanks to the availability of the test infrastructure, because ORAN is something you must do and nothing you can simply buy. So we discussed that yesterday. And this is, I think, one important element of cultural change, also for the operators. And last point, because it's a pretty new learning from me from the events the last days. So, because we had this academic discussions around Open RAN the last 2 days, and there were one very clear statement, and this guy said, a professor from Dublin, he said, hey, thanks to Open RAN, I can work with students and train them in modern mobile wireless technology. And he is right. 10 years ago, the differentiator between a chair for communication was, do they have some old Nokia equipment or not? So, yeah. So, and the point, that was the reason why, or is one reason why Wi-Fi is flying that much, because all the students learn that in the lab. It's cost efficient, it's easy, it's open. So, and we should keep that in mind when we think about the long-term change of or transformation of the industry.
Yeah, that's the beauty of open systems.
Sorry.
Yeah. No, very, very interesting. I think that's the beauty of open systems, that you can bring a lot of people working together on the systems, doing research, having access to the open ecosystem, and not also for the academia, that you are not forced to collaborate with big vendors, but you can set up a framework or an ecosystem by yourself.
Yeah.
Absolutely. Okay, so I have also prepared a second round of questions, but I now spontaneously also want to take the chance to ask here in the audience if there's a specific question to our speakers today. So I have the microphone, I can do the microphone guy and can just come to you. Is there somebody who has a specific question? Yes. Dankeschön.
I have one question about network sharing. Open RAN seems to be a perfect environment to open the networks for network sharing, but this is not much discussed. Not here and not much in the policy discussion as well. And the question is why it isn't. So is it too early maybe for that? So you can share a lot of components in an Open RAN environment. Why it does not happen and also not discussed?
Well, I think maybe this question goes a little bit to Andreas from a Deutsche Telekom perspective, but
okay.
Happy to invite everybody. I also have our own answer to this.
Yeah. So because you cannot sneak out as Telefonica. So first, looking at the economics of RAN, etc. So network sharing is important. It's an important element how to make it efficient, especially in the areas with low population density, etc. There are other reasons. So in a city, there are limited space. You simply cannot find new locations for RAN sites, etc. So there is an economic pressure for sharing of resources. Keep it that way. So, and B, operators are already doing that. So in 3GPP, you can find different approaches, MOCN and other things. And even just in the transport business, there's an approach of sharing. So DT serves Telefonica, for example, with front haul, back hauling solutions. Yes, these are the first steps. And I 100% agree with your statement. We must discuss that more because, yes, with this new, more software-driven, cloudified approach, there are a lot of more options to share resources. And we never thought enough about that and never made it an exercise to define it as an input for the standardization. And by the way, that's a weak point in the standardization. We always think in very linear production models, but the reality is there are a lot of entities who contribute to this linear production model. And to think more about the business interfaces and the business meaning there, and how to make it happen with an API, for example, that would be a good point.
Yeah, so I can just add also from my perspective, I also think that sharing will be the future or a big topic in the future in telecommunication market because of two reasons. The one is the areas where we currently do not have sufficient network coverage are these areas where it is most expensive to roll out network, like for example, the line coverage alongside railway tracks or in rural areas. And their sharing from an economical perspective makes a lot of sense. And the other aspect is, or the second aspect is that it will be easier when you build it based on cloud RAN solutions. I also believe in this. And the third aspect is also that there is still a long-going economic pressure in the telecommunications market in Europe because there's not so much growth opportunities in a market where every customer has a mobile phone, and therefore the pressure on getting more efficient is very high in the market, and this also leads to stronger discussions about sharing opportunities. We have seen this more in passive infrastructure so far with building up tower companies and things like this. But in the future, we will also see this a stronger discussion about sharing active technologies, and this also should be considered when you develop the future of Open RAN, I think. Okay, so we have 5 more minutes. Is there one more question from the audience? Otherwise, I also have some more questions on my list.
Okay. Just maybe quickly,
Yes,
say we have 5 more minutes. I thought we had 5 seconds left.
5 seconds? No.
I think it's a very good question to raise the RAN, right? I mean, if you're sharing today, you will also be sharing tomorrow, irrespective of what you have. But I think that if you go into 5G, in particular 5G standalone, there are some additional complexities in terms of slicing that makes sharing not straightforward. Or at least some of the sharing models we have today might not be supported. And given O-RAN is targeting 5G, of course, if you look at just the generations, as well as 6G, I think there are also other fundamental issues that needs to be resolved before you can comfortably share in a more modern setting.
Okay, one more question.
I would like to ask you about the topic that really interests me. It means the non-terrestrial networks. So taking the radio equipment and maybe some of the core network equipment to the satellites, to space, because that can be a real game changer in that mobile networks technology. For instance, for the Himalayas and the people that the network coverage in the places that the network coverage isn't good. So I know that the specification right now just started to happen about these non-terrestrial networks also in the O-RAN area. So 2 questions. First, what is the expectation for the future? When it will be available for us, I mean for the users, to use? And the second is, do you already discuss it with the manufacturers, that technology of the non-terrestrial radio, for instance? Thank you.
Very good question with a lot of interesting aspects, from technology to spectrum policy to coverage targets you have for different areas. So you can discuss about this even for a whole standalone panel, but Maya, I think this is also one element of the future vision for the development of Open RAN to integrate also satellite connectivity. So therefore, I want to hand over the question to you.
Thank you. Well, a very interesting question. We are not putting a large focus on it, but as we can always see topic development by members who want to join or potential members, that's increasing. Academics are increasing this topic, or suppliers who are looking into that, or academics who are looking into that are more asking to join the ON Alliance. So certainly a very important topic. But I would say 95% right now of the work we are doing for the next and for the release trains, it's really more not yet there, but certainly coming.
One more aspect from your side regarding the relationship between satellite and mobile connectivity, or?
Yeah, okay. So
that's always a difficult thing for telecom operators.
Yeah,
because it's
somehow
challenging
difficult. But technically, it's obvious. So it's a technology that helps to to close the white spots, even in Europe. It might be a good technology for getting higher resilience, backup capacities in case of failure of the terrestrial networks. That's a point, and there are already trials and activities and projects. I think that even DT made some press release about it, so I can't remember right now, but there are activities, sure.
So I'm a board member in Greenlandic incumbent Teleco, and Greenland is about 55,000 people there. 50,000 live in the capital, and the rest is spread along the west coast in small settlements, typically with, say, from 10 households to 100 households, but really spread. There's no road infrastructure. You have to sail, you have to fly. And we use satellites several places for connecting our local mobile network back to our central in Nuuk. And it works, it provides service, but it is certainly not as robust as you would be used to in a terrestrial-based network. And there are latency requirements that is difficult to meet, even for a low Earth satellite, again, depending on where do you take the signal down. In our case, we take it down in Spain. Then we have subsea cables going to Copenhagen and then back to Greenland. So you can imagine that even if it's a low Earth, the latency is... So there are certain applications simply not built for that kind of latency. So I agree with Andreas that in order to create availability and robustness of your network, I think it's a super interesting alternative. If you are in a situation where your country infrastructure has been smashed or destroyed in a conflict situation or natural disaster, having the capability of getting base stations still to work in a more autonomous way than what they normally would do, I think satellite is probably one of the only solutions to it for that. Yeah, I agree.
Okay, very good. I see that we are still waiting for our guests from the political arena, and therefore we just will continue our short discussion. And the good thing is there's one more question, so I can still wait to come back to my moderation cards. So I want to integrate your question also.
Yes, thank you. Thank you very much. Ian Ginn, here with Brian Opos, observer of the industry and an active participant as well. I've heard from, I think it was Kim was saying, start with disaggregation. So I think we started disaggregation because we could. But I still think we're answering the question needs to be answered as to, should we? If you see what I mean. I think that's where we still are. But the other thing I think in the telecom industry we just often miss is the customer. So at the end of the day, it has to be driven by a customer. It has to be someone that has a need. Now, it can either be the operators. We all know that operators struggle with operational costs or development cycles, or do we mean the end customer? I think in 6G we're thinking about sensing, and also maybe the intersection between Wi-Fi, which was mentioned briefly, and small cells, that sort of area where this could actually fly. So, yeah, as I say, who's the customer and why are they going to buy it?
Okay, coming from satellite connectivity to small cells now. Yeah. What do you think is the future of a fully integrated system between small cells, macro cells, and hyper macro cells from the satellite connectivity? Do we have a vision for this in the future?
So wasn't the first question about disaggregation? So can we take that first?
Yeah, for sure.
No, sorry.
That's why we feel comfortable. not the customer, but the technical question.
Okay, sorry. Now you convinced me. So yesterday I showed one graph about traffic distribution in DT's network. So also as a reminder, we very often talk about RAN. We focus a lot on RAN. But looking at the overall numbers, and I'm pretty sure it's not that different in Telefonica. So all the operators that operate fixed line business and the wireless business may see the same numbers. So it is 90% traffic, aggregated traffic. Peak load comes from the fixed line, and it's 10% that comes from the wireless, from the cellular network. And if you look at the numbers of the wireless network, most of the traffic is generated and consumed indoor. Yeah. So looking from the design perspective or the architecture, it may make sense to think more about how to build the perfect indoor network. And that is perhaps a link to the question about the heterogeneous networks, small cells, etc. So looking at the market, I think this idea is flying around quite a while. So all the studies dealing with more integration or with small cells, femtocells, whatever, most of them showed that there is absolutely no economic reason to get out of the Wi-Fi solution that we have so far. So that's the economic reality. And the beauty that we may get from seamless handover and all those things is not convincing enough for a customer to pay more. Sorry.
Very good. So I think now we are coming to the end of our discussion with this, let's say, last sentence about the market reality when you sell connectivity products. So thank you very much for this little discussion round. And now I think I will hand over to Marina, who then welcomes our political guest here on stage. So thank you for joining the session and enjoy the day here.
Well, yeah. Thank you to our speakers. Yeah, we have so much food for thoughts now, and we built a bridge to the political part of the keynote now, but we are still waiting for the state secretary. So I would like to send you to the coffee break, but not without telling you to come back as soon as possible, as soon as the state secretary arrives. But I would like to let you enjoy the first coffee break and to have some networking. Of course, do not forget to have the first look at our... He just arrived. Oh, wow, that was good. No coffee, stay here. Awesome. Hi. So it's now a special pleasure for me to welcome on stage Thomas Jatzombeck, Parliamentary State Secretary to the Federal Minister for Digital and State Modernization. The stage is yours, Thomas. We're very happy you're here. Hi.
So thanks for having me here this morning, and sorry for being late, but I'm fast with my bike, but I got a wrong address. But finally I made it here. So I went the extra mile to come here. Isn't that so bad, or is it? So it's a huge pleasure for me also to say it's the first time for me to be here at the i14y lab, and so I heard a lot of mysterious things about what's going on here, and great opportunity to see it really in life. And right now you're existing for 5 years, and so this is really a huge amount of time and a huge track record. And to start from a political point of view, some days ago, whole Germany was debating about Huawei and the Chinese influence on our mobile networks and what to do against that. And the magic word was always to say we're going for Open RAN. So this is our opportunity as Europeans, not only to come back to the market, as we never left it with Nokia and Ericsson, as we still have some big players here when it comes to mobile network infrastructure, which we could not say, for instance, when we look at cloud services or others, where we have to gain a little bit more market share to get relevant. But I think it's a fascinating development of technologies, and software is defining the world, and when it comes to more interoperability, I think this is the way to go. And with respect to Telefonica and Telecom, very engaged here, but there's also a new network player in Germany, and so the argument was always we're the first ones going for Open RAN. And as it seems, competition is fostering innovation, and I see also that Telefonica is engaged here, Telecom is engaged here. And I think this is good, and it's a way we have to go to build Open RAN also as a technology that really hits the market. My impression is it's going forward, but there is still a way to go. And the i14y lab, so I was told, is really a key player to foster this development, and you have established a certification framework for Open RAN components. I think this is really key, and issued already the first certificates and badges for Open RAN in Europe. And you're recognized, officially recognized partner of both the Open RAN, the ORAN Alliance, and the Telecom Infra project. You seek actively and maintain international cooperation, for example, with the NTIA in the United States and the Industrial Technology Research Institute in Taiwan. And you hosted important community building events such as the Plug Fests, interoperability tests, and of course the yearly i14y Lab Summit. And it has become a strong voice in the global Open RAN ecosystem, influencing discussions, shaping standards, and creating visibility for European contributions. And so these are major accomplishments, and everyone involved can be very proud about what you have achieved right now. So, but the way, as I already said, is going forward, and there are also some challenges that we are facing. The first is that multi-vendor environments are inherently complex. So, and this is not only the case when it comes to mobile network infrastructure, it's the case everywhere. And ensuring interoperability, performance, especially performance, I think is always a key problem there, and reliability across components from different vendors is not something that just happens automatically. It requires rigorous testing, well-defined interfaces, robust orchestration, and a lot of coordination effort. And to be honest, many so-called Open RAN deployments are still single vendor in practice. This is not a failure, but it shows that true openness is still hard to achieve at scale. And secondly, Open RAN requires new skills, both on the vendor side and on the operator side. Skills when it comes to DevOps, in automation, AI-based optimization, and also in managing multi-vendor ecosystems. So there is a steep learning curve, especially for operators who are used to turnkey solutions. Deutsche Telekom, for example, has made some bold strategic decisions in this area, as Wolfgang Kopf outlined here last year. But we must be aware that thriving Open RAN ecosystem requires long-term commitment. So, as every time, it comes to the long track. And commitment in terms of people, in terms of processes, and of course in terms of investment. So let's not forget that openness and virtualization also increase the attack of surface. Cybersecurity is not an add-on, it's a core requirement. Mobile networks are high-value targets for cyber attack, and that means we need standardized security frameworks, strong identity and access management, continuous monitoring, and rapid response capabilities. Open RAN must not become a weak spot. It must be secure by design. So, and that's what you're going to do here today, and therefore a warm welcome from my side. And our team is here, and we are very interested in seeing how developments go on. And for us, it's crucial to be in the front of the development for the next generation of mobile networks. And we also want to stay and get a real good site for development of these technologies from the industrial point of view. And for me, as being a member of parliament for Düsseldorf, and a lot of these vendors also are in my constituency, I know this also from a close point of view. So our full commitment to what you're doing and our full support, and for us it's absolutely crucial to stay here as a strong industrial leader. So all the best for your conference, and have a good time here.
Right. Thank you, Thomas. Thank you very much. Now you are the part of the i14y lab as well, and also a part of all the mysterious things happening here. So, well, yes. Thank you for a very insightful keynote. We built the bridges to the policy, and now, as I already told you, there is a coffee break to mingle, to network, and also to visit our marketplaces, where 12 particularly exciting lab partners are presenting their innovative solutions. So some of mysterious things are happening there as well right now, so enjoy them. You will reach them just following the hallway. I also would like to remind you to register for interactive deep dive sessions, which will take place, as Andreas just said, in the main stage on the 5th floor, and then you can switch. So first come, first serve. And one another organizational remark: today is a National Warning Day. Don't get alarmed by the alarm signal. You will probably receive it on your smartphone at 11. So it's just a trial alarm. Do not leave the building. We're still here. We still go on with our conference, and see you at 11:15, about 11:15. So have fun. Enjoy your break. Welcome back from the coffee break. I hope you enjoyed it. Some are still enjoying, obviously. Welcome to the second block of our summit, dealing with consistent and repeatable testing and the operator's water cooler moment in testing, asking the question: what is needed, what is missing, and what is working? Please welcome on stage the panelists of the panel Talk 1.
Do we still wait, or do we just start now? The timing is counting down, but we're sort of 1/3 of what we probably could be. So let me just welcome the two co-panelists, Gerald Huber from Telefonica and Peter Lettel from T-Labs. Deutsche Telekom, but T-Labs is the most important thing. So super excited to be here with Gerald and Peter. And I think that the topic of today is really about testing, as it says up here, and what we need, and also, of course, what is working. That's always good too, but it's never really necessarily always interesting to hear about all the things that works. It stimulates us much more to hear what are the challenges ahead in terms of what we are missing or what might not be working so well. So basically, let's kick it off with Gerald. Would you start out sort of just maybe very quickly presenting yourself, and also in your opinion, take it from there. What do we still need, and also if there's anything we're missing.
Okay, so hello, my name is Gerald Huber from Telefonica Germany, and I'm a senior innovation manager, so I'm taking care about new stuff. More the practical part, so also here in i14y, the representative of Telefonica. So what do we need? So as I said, I'm from Telefonica Germany, so we're an operating business. We are not the Telefonica global part. So the global colleagues are really taking care about the very far future. We are more still into doing 5G. Sorry, I know this may be over, but we still build it. And so for me, the thing what we need as an operating business is really we need things we can build. Operating business means we are factory. So we are optimized on building fast, very efficient, high number of sites, or rebuilding them or changing them. So that's really key that things are working, and also for running them. So in operational, the automation is key. All these things, I think, are part of an Open RAN discussion, so that we need to have serious tests so that our things are interoperable. So we need this, and things are working on automation level, so having maybe not the rig, but something similar, or which is taking over the function of doing things automatically. And unfortunately, we're not very far there.
Right. No, that certainly could make sense. Peter, also to give you the chance to just briefly introduce yourself, and you have been involved in Open RAN for quite a considerable part of the last 10 years, I think, or 8 years at least, and have gone through a lot of stages from original design and strategy, vision, to a lot of the intricacies of the testing part as well. So give us your view on this.
Thanks, Kim. Thanks everyone for having me. And yes, as mentioned, so I recently joined T-Labs, but as outlined, so I had a pleasure to be with the Open RAN topic from day one, and saw the whole evolution. So from the broader perspective, of course, in order for operator to be able to deploy solution and deploy it at scale, it needs to be performant. It needs to be at least as good as the existing solutions. It has to be as good, not only performance-wise, but also TCO and cost-wise. And as we all experience during the period dealing with ORAN, of course, disaggregation still brings complexity, and having a chance to deploy solutions in a multi-vendor way, it also has considerable requirements on being able to test it in an efficient way. And of course, a community has been working hard on developing test specification, test frameworks. We have also made great progress building a kind of industrial alignment, and also community of open labs like i14y lab here. That is helping industry to bring components to early integrations, do testing, and then for operators to be able to reduce efforts on it. Is all already in place to be able to do that? Probably not. We discussed here. So how can we automate all the process? How do we make sure that the efforts that is done in the open lab is then really propagated to the real operators labs, and reducing efforts they need to spend in the introductions process. So I think this is all continuous process to increase efficiency, and towards the end, making sure that the solution is as performant as existing ones, and it is also commercially attractive.
Oh, I mean, I think that's clear. I mean, so one thought I have on this topic that I got to know of yesterday, I had to be the moderator of, is that I talk often with smaller operators that are not necessarily part of a larger group, or investors that invest into, let's say, smaller operators, particular targets. And one of the points I often hear from them is like, this really looks very complex, and it's rather intransparent. How could we, as a small operator that might not have thousands, or let's say 30,000 or 100,000 of sites, benefit from Open RAN? And I think maybe because of the brand, or the picture that these operators have in their mind of Open RAN is sort of this mix fest. You basically just take a maximum mix, and that sounds very complicated and to integrate. And if you don't have a big organization to do that, it becomes very complicated. So I'm very interested in when you look at engaging smaller operators or getting the general idea about what Open RAN is, everybody knows that the testing is super important because it has to work from day one. Or you don't take the risk of exposing millions of customers to this new technology. So how do you ensure that confidence is sort of not only on our level, on a DT, Telefonica, Vodafone level, but actually also something that smaller operators might also embrace, which I honestly think is a bit of a challenge of what Open RAN has today. Is it clear what I ask?
It is. What I'm thinking just about is, of course, I represent the tier one big operator, but trying to get into the shoes of the smaller ones. So you are completely right with the sentiment. So you do not have that capacity, that organizations that really build new solutions. But I think that one of the approaches could be that you probably be kind of a smart follower. You look at the solutions, even if these are multi-vendor and if these are working in DT network or AT&T network or other big operator network, probably it would work in my network as well. And what I would see attractive from a disaggregation point of view and all the topics we were discussing here also today, the openness give you an opportunity to focus on how you, as a small operator, wants to differentiate on the market. You can really pick up the solution as a basis that was done by big operators already, but you can focus on smaller customization that, by nature, from the disaggregation approach, can be done. So I would see this as an opportunity as well, in a sense.
Yeah. Okay. Gerald, do you have a view on this, opinion about this? How do we get it? How do we engage a broader community of operators?
I think the ease of use is key. So it has to be easy, and I think Open RAN shouldn't be this religion, as you're afraid that maybe some people think it is. It should be a part of it. So I think we won't have an Open RAN network exclusively and then closed RAN network exclusively. It should be a smart mix, so where we need it. So that also a smaller operator, if he thinks it's a good idea to have something else here, because Open RAN or cloud-based or distributed RAN does bring some benefits also from bringing the core to the radio. So if we are able to make this very easy, automated, then you can mix it. So you can have a site here with this function and another site there. And if this is working seamlessly together, it would be easy to integrate. So this could be take away the frightness of a smaller operator being overwhelmed, having automation to bring it in the network.
Right. I mean, the reason why this is an interesting discussion is, of course, that there are quite a few operators who are not Telefonica, Vodafone, or Deutsche Telekom in the world that hasn't really started their 5G journey yet. I mean, most of the bigger operators in Western Europe and the US has already invested massively into 5G infrastructure, and it will probably take another 5-7 years before they will reinvest a lot. So if you want to have low-hanging fruits in terms of an opportunity, smaller operators might actually be the biggest opportunity to return on O-RAN in the short term. And of course, they will not take that risk unless they are sure that it actually works. So having a kind of workbook or guidebook for why this could make sense, I think is important. We don't have that much time, but I want to look at the elephant in the room. You can look around and where's the elephant? And the elephant is, of course, security. I mean, we know a couple of years ago, a particular Strand consult in Denmark, actually a good friend of mine, and you can take me out and hit me later, has been very critical about Open RAN from a security perspective. Now, I know, and I think we all know, that a lot of things has happened, but let's talk about security in terms of where are we today? And yesterday, I think from the BSI in Germany, we understood that there might still be some way to go in order to feel completely sure about that. But what are your perspective on security, cybersecurity in Open RAN? Let's start with Gerald.
Well, I think security and automation and high speed of automation is something not very well working together. So if you plan to have software releases daily or something like this, it's very critical. So I think we need to. It's a key, of course. We don't have to discuss this, but we probably won't test things until that's in the lab. So there probably need to be smarter solutions. Of course, it has to be part of the DNA of the Open RAN itself. So it cannot be that someone is delivering something which was in the past reality and still has huge security gaps on the hardware. So this cannot be. But we also need to take into account that we want to be fast. AI will change things, so we need to be sure that the AI is doing right things. Right. So it's the next level, I would say.
Yeah, Peter, your perspective.
No, I definitely agree in terms of that security is of utmost importance for everyone in that environment. Also from the ORAN Alliance perspective, there was already in the past a lot of focus put on security-related specifications. Of course, everybody understands that moving towards a further disaggregation is increasing the attack vectors. On the other side, also brings much more transparency. You work with open interfaces, so there are also some opportunities. You have smaller software components you can much faster adapt and develop security-related patches when needed. So I think that the industrial alignment and effort to bring the right level of specifications as a framework has improved significantly, and in the ORAN Alliance there was a lot of focus spent there, and I think that this is at a very good stage. But of course, we can never sleep because, of course, this is evolving, and like you mentioned, so all the developments towards AI. So how do we create a framework that on one side allows AI to bring the benefits into the network in a multi-vendor way? So how can we assure model exchanges and communication between AI agents on one side? How do we make sure that we automate all the lifecycle management and integration into the management system? So these frameworks they need to be developed, but then also including security. So how do we assure that the AI agents have identities, they have verification credentials, they have all the security capabilities that are needed, because this is obviously seen by a big area to make sure that is solved.
So Peter, just because we don't have that much time left, I just want to stress this, because if that truly has to replace the critical infrastructure that some operators have in Europe, that from a European Union perspective we would like to get rid of, and we are using the argument that Open RAN is that replacement, then of course it has to work. It makes no sense that you replace something that actually works very well today, but comes from the wrong country, with something that has huge security risk in it. It of course makes no sense, and that is not something we can recommend to the policymakers. But it's super urgent to do it, to protect our critical infrastructure, particularly in the world we live in. So that you guys have the eye on that, I think is very important. Not very long time left here. Peter, what is the biggest challenge you have from a testing perspective at this moment? Shortly, please.
So I think one that I would mention is then, as much as we are good at bringing specifications and test cases related specification to ease that process, you always have in reality some sort of extra features that vendors are developing that are not yet captured in the standards, and you always have certain extra capabilities that are to an extent implementation specific or sometimes proprietary. So how do we keep the speed of specification and bringing these innovations quickly so that they are reflected and can be then tested in an efficient way?
Okay, Gerald.
So I think what we are already working on is meaningful tests. So not testing for testing, but testing for reality. And I think we need to feed back our learnings of our tests into the standards, so the standards getting better, and we get more out of the standards and quality.
Am I allowed to breach the time completely? No, I mean, actually, there were quite a few people who were very late. The last question, and that, Peter, that has to be, if you were the CEO, would you replace your existing infrastructure with Open RAN today? Yes or no?
If it brings benefit, yes.
Gerald?
I would never replace any hardware today with another because it's way too expensive. I would do it where it makes sense.
Okay, that was a political answer. Thank you.
Thank you so much for the insights, dear speakers. And now we are switching to the next water cooler moment and announcing the next panel about energy efficiency. Please welcome on stage the speakers for the next panel.
So, thank you very much for the introduction. Yeah, we are picking up a topic which I think is related to testing, but also picking up the topic that we concentrated on last year, which was on energy and energy efficiency. And I have to say, if something hasn't changed, at least in my daily business, in the past year, then that's the attention on energy efficiency, energy reduction in any parts of the network. And so this is why I'm very glad that we now have a couple of about 20, 25 minutes, I believe, to talk about specifically, again, this topic of energy efficiency, what has happened. And I'm very glad that here on the panel, we have, I think, a small, really production chain along the ORAN networks, mobile networks, from components, systems, towards the apps. And that's why I'm very glad that together with you, we will now be able to discuss this topic. And yeah, in order to kick this off, I would be grateful if you have a brief introduction, 1 to 2 minutes, and what your connection to the ORAN community and energy efficiency is.
Sure. Yeah, thanks. Thanks, Michael. So my name is Neeraj. I came from the Santa Clara, California, work for Dell. And part of my team is actually, the Dell has created a lab called the OTEL Open Ecosystem Lab. And from last few years, we are trying to figure that out as part of the ORAN. It mentioned basically disaggregation where how the hardware is actually catching up to. So if you talk about the energy efficiency, everything matters basically, every watt matters. And we basically trying to validate that how, when you're trying to run the stack basically on a particular platform, is it up to your mark or not? And what are the gaps if you are compared with the traditional RAN? And what is that parity and what exactly we have to do? So I'm going to talk about that a lot. And in order to that, from last few years, I also created two white papers and mention about a lot of details in that, what's going on.
Okay. Yes. Thank you, Nash. Alberto.
Yeah, Alberto, working for Analog Devices. Analog Devices is a global semiconductor leader. One of our big focus areas is chipsets for mobile radios in the world, Open RAN and non-Open RAN. We are very much involved in power. It's one of our priorities. If you're looking at a network today, about 70% of the power goes into the radio. And then if you look inside the radio, 70% goes to the PA. So having a good chipset and trying to save power is very relevant and can save a lot of power. And by that TCO, because that is, if I talk to operators, it is always about TCO. So myself, I'm leading a systems team. I'm about 30 years, a little bit over 30 years in this industry. First 15 years in handsets, last 15 years in infrastructure. So.
Okay, thank you, Alberto. Martin, over to you.
So I'm Martin Hoffman. I'm a technical solution manager with Remedial Labs. And with Remedial Labs, we are, let's say, an R&D powerhouse. So our main focus are XApps and RApps, but we also offer some training, so applied to research projects. And we are the part of the ORAN Alliance, part of the AI-RAN Alliance, and with our projects we are cooperating, of course, with the T-Labs, with the i14y Labs, who invited us here. Yeah, but also we had a cooperation with Juniper Rig, where we implemented our apps, and with Keysight and Viavi, who offer the testing services to test our applications. So regarding the energy efficiency, we are having a few XApps and RApps that takes the problem from a little bit higher perspective than Alberto mentioned. So we are looking for the network as a whole, so how to switch off the cells depending on the traffic, or how to reconfigure the number of active antennas in massive MIMO, and how to do it using the rig and XApps and RApps.
Okay, thank you. So, gentlemen, to get the discussion further going, I was wondering whether your global view, I mean, you're representing really, I think, global companies, and you have a view on what's happening across the different industries and continents. What is your view on the role of energy efficiency? Sometimes from the kind of German, European perspective, I thought this is a very specific European kind of topic related to public networks. Is this the right perception? Or do you perceive this as a different discussion also in other parts of the industry?
It's certainly it plays a very key role. And without having the system very efficient, I don't think this technology can make it. And it is very important that to make sure that starting from the radio and to the stack hardware that hosted the RAN stack, and plus all the backend components, they are all very energy efficient. But how do we measure really? That is one of the critical part. And that's where I will reveal a lot of information about it, and how industry is basically making improvements, and especially Dell and Intel also kind of making efforts to make this as successful. So that's where I stand currently, and I will basically provide the more information after that. And please for the next question.
Okay.
Yeah, I think there are two parts in this question. So one part is geographically, is there a difference? There is, but in both, all over the world is important. If you're looking at the electricity costs in Europe, they are higher than in North America, for example, and that has an effect on your total cost of ownership, and that makes your balance slightly different on how important it is. But again, in public networks, I see that request back everywhere. If I'm going then to private networks, I see absolutely a different balance there. Because if you are a factory owner, for example, you're going to install 5 small cells, it doesn't really have that much big of an influence on your electricity bill. You have heavy machinery there, that is really your electricity bill. Also, your total cost of ownership there is probably much more around servicing and other places than the electricity, which is, for an operator, one important part, the electricity bill. So I do see importance, but especially between private and public network, there are differences which are substantial.
Okay, thank you, Alberto. Martin, your view.
Yeah, so I think I will mostly agree with what previous speakers said, that it depends somehow on the region. So probably in Europe we are a little bit more focused on that, maybe in US a little bit less, but I think that if this energy efficiency brings money to the operator, then it is a good case and it is important. So I think this is how I see that, and I see that it might also be interesting to take into the account the XApps and optimization algorithms itself, and especially if they use some big AI models, and then to consider if really the power that is consumed to run these models and the effort that or servers that requires to run the RAN optimization algorithms, does it bring the benefits in overall, yeah? Or not to spend too much energy on energy efficiency optimization algorithms. But it might be interesting case also to look at.
Okay, thank you. So I think we have also the privilege of you gentlemen having views and experiences from, let's say, at least two sides of the industry. One is, let's say, also you're dealing with, let's say, traditional mobile networks and operations, as RAN, as we would call it, I think these days, and also O-RAN. So from an energy perspective, do you see any differences, potentially any advantages of the Open RAN architecture compared to SRAN?
Yes, certainly there are. The whole design and whole idea is basically of the Open RAN and O-RAN, you call it. It certainly is being the more flexible, more dynamic, and more energy efficient, because so much capability. If you compare it with the traditional, which is monolithic and static and not much you can do, here is you have a lot of flexibility and so much innovation in every part going on. Overall, basically, everybody's effort is to going into the same direction, and then they have to achieve basically better than what it used to be. And certainly, let me give you an example basically here. So I started a 5th gen server, XR11 Dell provides, which uses a 3rd gen Ice Lake CPU. And we did some RAN workload on that, and then we compared it with the next gen 16 gen hardware, XR8K, which uses the Sapphire Rapid 4th gen CPU. What we have seen, the capacity of the spectrum processing capacity is doubled, okay, and plus the energy efficiency we gain around 15 to 20% for the same workload. So the kind of the improvement going on, and plus now we are waiting for the Granite Rapid. You must have seen that GNRD. That is the next CPU is coming out, and which will double the processing capacity of the CPU again. So earlier you used to do the 10 cells, let's say 44R. Now you should be able to do 20 cell, and plus it will give you another 15 to 20% another basically efficiency, power efficiency gain in that. So overall curve is basically efficiencies keep on growing and capacities keep on growing, but the overall cost basically will go down for hosting the entire workload.
Okay, thanks. That sounds very promising.
Yeah, I totally agree, by the way. It's a very good answer. I would like to add that what I like about Open RAN in general is the ecosystem from universities, institutes, startups, and established companies working together. I believe that creates a better innovation environment than just a single company. Not a single company in the world is good in everything. So that I really like of Open RAN, and that's a great opportunity. Now that said, what I would like to see, so if we are looking in my own situation, the radio chipset, we can do a lot and innovate there a lot. Then we are looking isolated to a radio. Now what I've learned in handsets in the early days, we did make the big progress on battery life for a handset when we started to look at the system level, not at component level. So if I'm looking at a RAN, there's where we can win. And unfortunate, Open RAN didn't specify, I think, yet enough to be able for us to, for example, use X and R apps. Because if we use R and X apps from one company, it doesn't justify if not all X and R apps has the same interface. And I think we can do better. I know in Workgroup 6, Workgroup 7, there are absolutely good discussions ongoing, initiatives. But I think there we can, as an O-RAN community, do better.
Okay, thank you very much. So before we move over to you, I think it's a good point, because this was something that I observed when we were preparing this panel, that somehow one thing we do in this community is anyhow talk with each other and exchange information. But I think we not only need this between the, let's say, developers and promoters, but also on the systems. So if you were to have a wish what to do better or what to improve, where are the kind of interfaces also between your different parts of where you work in the bits and pieces of ORAN, where you would hope for, let's say, better exchange of information or better interfaces in order to improve, for instance, energy efficiency?
Yeah, so I think a very big wish, and I think we also talk a little bit about that during our morning discussion, is the maybe not interface itself, but I mean even bigger principle that availability of the data. So because okay, there is some demand from operators or our customers, so show us that your solution, your XApp or your hardware or something brings energy efficiency benefits, and like show us on the real world data, and we'll be really happy to show that on the real world data. But then it comes some, of course, justified legal issues and so on with sharing the data, but it then stop us from testing our solution on the real data and to demonstrating the benefits. So I think if there was some wish on our side, it was the wish to have more data from the real deployments public, so we can train our models, we can verify them, build some digital twins to test their impact on the network, and yeah.
Okay, thanks.
Want to add to it?
Yes, please.
So certainly, you know, I like that idea, ORAN supports that there are interfaces provided to manage the power. And the good thing is that using that interfaces, you basically, like if you take the architecture of the XR8K, which is the slate-based server, so you might have multiple slate in a single chassis. And you know that every day the load basically does not remain consistent. It goes peak, and then during the night it goes basically off peak. So it basically vibrate like sinusoidal kind of thing. So you can take the advantage of that using these API. So you can offload from the your workload from particular sled to another sled when during the off-peak time. That will basically give you the tremendous amount of power saving. So that is the architecture like going on for the cell site for DRAN especially, and that's where all these APIs will be very helpful. So how do you dynamically maintaining and shutting down the the power system that is not required. The radio is like cell is certainly one of the thing, no doubt, that transmitter, TRX chains and all those things. But how do you handle the server side? That exactly I'm talking about. So you can do basically shut down the power of the particular sleds and offload. Before you do that, you offload the basically workload from that to another one. So that's how you get basically an energy saving.
Okay, thanks.
I want, maybe it's a little bit slightly different discussion, but if I'm talking with my colleagues in analog devices on data centers, I'm really jealous the amount of data they have about power distribution. We get from operators like DT and Telefonica, Vodafone. You do your best, but basically it is very, very, very basic information we are getting. And with that, we need to do algorithms. We have in our chipsets machine learning algorithms, but we have to do that basically on hardly any data. So if we could improve that in the standard, in a way that we're really going to measure. If I look at data centers, they are measuring and they are putting their cooling connected to that. They do maintenance schedules for that. They are looking at backup solutions, resilience. So there is a lot with that data to be done and optimized. And I think there absolutely we are, and we can learn a lot. Maya, you mentioned intelligent copying, I think it was, right? Go to data centers and let's intelligent copy this. I would say absolutely.
Okay, yeah, thanks. So I think there is quite a big plat for this kind of sharing more of data and information. So this is something that I took away from our initial discussion already. I think it's a topic that also close to my work because we are also depending as an operator on the own data that we see. And one of the observations that I made the last couple of months was that, for instance, if we look at standard information from our systems, it's typically in 15-minute intervals, something like this, that we get. And we honestly turned to our colleagues in the i14y lab and we're asking whether we have any other timescales we could get down to, so with a higher granularity. And they said, well, yes, of course. Yeah, so Raj, for instance, told us, yeah, so there's a whole list of things that I can get from a Dell server per standard, and I just need to trigger the request, and off we go. So I think there is quite a discussion to be led also in this industry, and maybe that's one of the advantages then of ORAN versus some of the other designs, that there is more interest in this data, and potentially there is more also participants in the market who somehow can deal with the information that is provided from the system, in whichever way this is being generated. But this is one of the takeaways from me, honestly, from the discussion we are having, as we are, I think, approaching the time limit of our discussion, which I think we could continue for quite a while, at least I could. I was just wondering what would be kind of your takeaways, or what would be the one request that you would have to the community for energy efficiency, what to do next?
Well, there are more things you can do on the server side when talk about, and especially dealing with the C states. So if you are running RAN stack, okay, and they are tied to a specific course, and some of the cores are not being used, you might put in the C6 state. So that will put them in the deep sleep, and that give you the extra benefit of the power saving. So what I have seen so far, if you're running 1 cell to 6 cell, let's say, and like load goes up and down, and you can basically trickle down your cells kind of thing if you do all those things. So what I've seen, fair easily you can take 25 watt to during the off-peak hours up to the 5 watt fair easily by all the cores that not being used during those processes, putting in the C6. So that's the extra advantage. That's the one thing I want to talk about. And another thing, the technology like low-side and inline is also like in the kind of people talk about. And what we have seen, we have analyzed both of them, and certainly there's our advantage of for both technology. So it has to be used very wisely because they fit in certain category based on the energy efficiency. If your spectrum is number of cells or whatever you call that, it's not that pretty high. So look-aside looks more prominent on that for energy saving perspective. If you go more higher and higher, basically dense, then inline is give you more beneficial. So these are all kind of the tools that in your hand. So where overall, performance per watt, every watt matters, and you have to look on every point everywhere, then where you can save more and more energy. Overall, all the game is then this is the single site you're talking about. If you combine all of them together, then that's where you basically algorithm data and all those things comes in the picture, how it can be playing. Every site has a different environment. The off-peak for one site may not be same for another one, and so the engine will be complicated, no doubt that. So that's the reason I agree with all the data collections and the algorithms you're trying to talk about.
Thanks.
Yeah, I think first of all the topics we have discussed in the last 22 minutes are relevant. Well, one specific point as an example is latency and slicing, because the most efficient way to reduce energy is just switching things off. We all know that. Now, what if you have very low load? You get all your symbols in. Do you really need to send it out immediately, or you wait? Basically you put your bucket full and then you send it at once. If you can do that, of course you create latency. So how much latency is acceptable, and these kind of discussions of what could you do there, I think you can gain a lot of power efficiency, and by offering different slices, like for example Deutsche Telekom is doing with low latency and gaming, then you can ask people that really want low latency and a higher price, but it also will cost more energy. So this kind of discussions at a system level definitely can help us to save even more.
Okay, thanks. Martin.
So I think on our end, such a wish or what we can do for energy efficiency would be very nice from our perspective to get all these things together, all these servers and radio units and hardware, and put the rig on the top of that and really try to build either here or with cooperation i14y lab with T labs to build start to building, like going out from the emulations that we did, that we verified our algorithm with Viavi, with Keysight. We show some benefits to really deploy something and try to see what are the to build the ORAN stack and try to measure something really really real and see what the XApps and RApps can bring on the top of that.
Okay, Martin, thank you very much. Alberto and Iraj, was a really pleasure to have you here. I could go on for quite a while, but I think we have other topics now to deal with. So I think we are done with our panel. Thank you for listening to us, and hope to pick up discussions also in some of the offline discussion situations during lunch and coffee break.
Yeah, thank you, Mike.
Thank you.
Thank you so much. And now we already arrived at our third panel talk for today with the question, what is consistent and repeatable testing and how do we get there? So without further delay, I would like to welcome on stage the speakers.
Hello. Yes, so my name is Carsten Rossenniffel, co-founder of EANTC, one of the i14y consortium partners, and I'm moderating the panel today. I have the pleasure here to have Alicia Wang from the ITRI in Taiwan. I have Ajesh PK from the i14y lab, ORAN verification engineer. Alicia is also an engineer, so we're really talking from the realities of the testing in the lab, and Ian Wong, who's director of RF and wireless in Viavi Solutions. So why are we talking about testing? Most of people think if you go to MWC and even here, like, okay, ORAN works. And of course, yes, it does work. But now we have the challenge. We are off the peak from the Gartner hype cycle, and now we're still not fully there yet at the level of productivity, as Gartner likes to call it. So we need to get things working in the lab. And that's more of a challenge in the daily work. Probably you don't want to hear all of this, so we don't want to bore you with too much details of the hard work that each of the people here are doing. But on the other hand, I think there are a lot of lessons learned. We've had a couple of experiences recently of lab collaboration. That's the topic of today's panel here. And all of us are collaborating in the labs between US, Europe, and Asia. And I would like to explain a little bit to you with the help of the panelists, like what is this about, what are our experiences, what are the challenges, what are the next steps, and so on. So let's get started, maybe just with an introduction of the background of the collaboration. So Alicia, if I can ask you first, like, what are your collaboration activities, particularly on the RIG, XApp, and RAP testing, on the network optimization testing at ITRI?
So hello everyone, and I'm Alicia from ITRI. And in this year, together with the i14y lab, focus on the RIG testing on the energy saving scenario. So our goal is to evaluate how well the RIG application can save energy in a large topology. So first of all, we need to build up the test plan, and for the tip using 9 scenario, and we get app supplies from the ENTC, Dutch Telecom, and Fraunhofer, and Zhonghua Telecom is the Taiwan's operator. And we also complete this test plan and deliver it to TIP for contribution. And we also build out the simulation environments using Viavi AI ISG to build up the large topologies with 52 cells and 800 UEs in this environment. So thanks.
Right, and Ajesh, from the i14y lab perspective, how are the collaborations going, particularly in the end-to-end testing these days?
Yeah, definitely. So hi, myself Ajesh. So collaboration for i14y lab means, we are an open lab here working with multiple vendors, multiple STOs, and also test organizations. So here we day by day deal with all these vendors, asking, testing things, and doing some joint activities. So this time for us, the collaboration, so as mentioned, so we have some collaborations already with i14y lab as well as Velar lab here. So for collaboration is for us is how to accelerate. So our own motto. So we work on a motto of accelerating time to the market. So how fast the products come to the market after testing. So whatever that really boosts this goal of making all these operators or the vendors products that can be deployed faster in the market. So in this point, the collaboration really makes sense to involve with other labs to do some joint collaborations in like testing or validation, so that all these results will deliver us a consistent manner, and as well as this really supports this ecosystem to be evolved. Yeah.
Right, thank you. And Ian, we've been working together between i14y lab and Valor. Maybe you can introduce that a little bit.
Sure. How many of you have heard of Valor? Okay, I would say 50%, so I don't think our marketing has been so successful so far, but yeah, so it's okay. So Valor stands for Viavi Automated Lab as a Service for Open RAN, Valor. So that acronym, actually I came up with that. Anyway, it is a lab in the United States. It's actually primarily based in Chandler, Arizona. Our Valor lab director is here, Eric, back there. So if you want to talk more about Valor, come to our booth. You can meet him. And it is funded by the NTIA, thanks to our NTIA colleagues that are here. So we are one of the 3 labs that won the NOFO awards in the US. And one of our goals is to really improve the ecosystem of labs around the world and improve our test plans in the ORAN Alliance, in TIP, and elsewhere. And that's basically what we embarked on, I would say, about a year ago. It actually just stemmed from a lunch conversation with Andreas primarily, and say, you know what, we have all these tests. We need to make sure that these tests are reproducible and repeatable across the different labs. And we found out some interesting things, which we will discuss probably throughout this panel. But and at the end of this panel, you need to know what's the difference between repeatable and reproducible. There will be a quiz, okay? But we'll cover that later.
Exactly. But first, thanks for reminding about the importance of lunch conversations. We'll try to finish on time. So that's actually a good point. That's a mouthful of the term consistent and repeatable testing. And we found quickly that we need to understand that very carefully, and also that one of the terms isn't exactly correct. So can I hand back to you immediately?
Sure, yeah, I used to teach a class, so we're gonna do it this way, right? Like, there's really 2 terms, at least officially, right? It's repeatable and reproducible. Who thinks repeatable is harder than reproducible? We've got a couple, 3. Who thinks reproducible is harder than repeatable? Got more? Well, in this case, the majority did win. So, reproducibility, right? And maybe let's start with repeatability. Repeatability means you do a test, and you keep on doing the test, and you get consistent results. So consistency is a characteristic of a repeatable test. But reproducibility is that you actually see that it's consistent across different test lines and across different labs. And obviously, that's actually a lot harder to achieve, because every lab has their own infrastructure, they have their own test systems, they have their own processes, and it's much harder to get to reproducible. But reproducible is something the industry needs if an operator were to trust an open lab to do a lot of their baseline testing, which was kind of part of the vision of this concept of open test integration centers, or OTICs, right? So I happen to also be the co-chair of the TIFG, Test Integration Focus Group in ORAN Alliance. And that's one of the tenets, is to actually have this network of labs that can offload some of the baseline testing from operators, again, to make the business case for ORAN definitely a lot better. So repeatable versus reproducible, don't forget.
Right, and Ajesh, so what do you think, how important is it, why is it important at all to have reproducible and consistent testing, particularly for the work we're doing at the i14y lab?
Okay, so I would wear the hat of an engineer here. So, because basically we do these testing activities all time in the lab, yeah. So whenever we collaborate with the other labs to bring up this repeatable testing reproducibility. So first thing we look for is, hey, how can we achieve this, yeah? So first thing we look for is, okay, basically what kind of specifications we would rely on. So basically we are now relying on 3GPP as well as the ORAN specifications. Then the next thing comes is, how can we make sure that test equipments or the reference framework is a golden framework where that most of the involved entity or the elements are literally the same. Yeah, for example, if vendor A provides us something to be tested and it has to be repeated across the labs, what the vendor provides should be the same with respect to the software versions, with respect to how it behaves. Yeah, only then if the equipment, if the unit behaves in the same way across all the labs, then only we can call it as repeatable or reproducible, right? So that's where. So we, as an engineer, we totally work that in a way that all the other elements which we require for the testing this particular element is literally the same or can be trusted. Yes, because if you test something and I test something and I totally get a different results, then it's not consistent or reproducible. So we have to make sure that all our test environments, everything is tuned and all the campaigns are proper, and also we make sure all the readings we take, all the measurements we do is really proper ones and as well as can be trusted. Yeah. Otherwise, if many labs have many results, then nobody trusts us. So especially operators, for whom we are doing it for the operators. So the operator should find the value. Okay, these guys have done so much things and it looks good and it is repeatable across the lab. Yes, why not test it? Yeah, why not trust this? So this is where we really focus on. So from the base, where we take the specifications, from how we read the values. Everything we make sure that everything is repeatable as well as consistent, as well as it's all reproducible as well. So I'm just saying from engineering point of view how we test this.
Sure, thank you, that's appreciated. And I think my experience is over the years since I've started doing testing, this kind of reproducibility comes only when the technology is mature. So after 10 years, it's pretty straightforward, right? Everybody understands everything clearly. Yeah. But now we have areas in ORAN, like rig testing, for example, which are very much research oriented, and you're very involved in that, Alicia. So maybe you can explain how you see the consistent repeatable testing, particularly for energy efficiency and rig testing.
Oh, thank you. So I think the consistent and repeatable testing is crucial for energy saving because this rig application is sensitive to the environment. For example, when the rig application executes the results in the 2 cells such as small topology, but in the large topology such as up to 52 cells topology, the results will completely different. And this difference or variation will raise the question is that if we observe these results, reflects the actual performance of this rig application or just the influence about the test setup. So before we executing the testing, we need to align across different labs to align on the standardized and the test setup topology. So thank you.
Yes, thank you very much. So now let's get to some more practical description, like what has been done. So we have run a pretty major project, or not project, evaluation of consistent repeatable testing between i14y and Valor Lab recently. And maybe Ajesh, I can ask you, what were the practical ways to getting to that level of reproducibility? So what needs to be done?
Okay, so as mentioned before, so the first thing is, as Ian mentioned, it was starting off our lunch conversations, right? So the first thing is to evaluate what we have, here, with the evaluate what the capabilities of the lab is, and what are the test equipments we use, what are the standards we see, how are the campaigns we have created, yes. So then, and finding this system under test. So mostly we did this activity using the end-to-end, where we had the radio from vendor A and the CUDU from vendor B. Yeah, so basically now the SUT is the same, and now we have to get aligned with the other equipments, because in an end-to-end there are multiple other elements involved in an end-to-end, like the core, the traffic generator, the UE emulators, and many things. So we want to align these, their configurations, and also, as mentioned, so when it comes to the testing, mostly the engineers refer the ORAN specification, right? So there could be a understanding differences in the understanding, because all these differences or interpretation of the specs really affect the testing. For example, if an engineer A interprets in a different way and he creates a campaign in a different way, and engineer B understands, oh, this is something what it's not really working. So he will define the campaign in a different way, right? At the end, you get two different results. So this has to be avoided. So we have to have a proper alignment with the labs, how to understand really the specs and how what is to be achieved, how to do it. And based on these alignments, we will make sure that all the other equipments are tuned, calibrated, and the readings we take is proper. And in that way, we make sure that this the units that is under test does not produce a different result, because basically it's the same unit that's been sent to the Ian's lab or the i14y lab, right? If I get an RU and he gets 1 Gbps throughput and I get 500 Mbps on the same throughput, then it doesn't make sense, yeah? And the operator definitely won't trust this, yeah? So all these are things starting from the specification to the alignment of the test equipments and how to do the test, how long it should be done, and how the reporting should be made proper. So all these alignments are done at an engineering level, and it's reviewed by all the managers and all the involved parties, and we make sure then we start this testing. Yeah, of course, then at the end, some point of testing, you will find some difficulties, but there we will make sure the root cause analysis is done, and also what exactly has gone wrong. So this is how we make sure that...
Yeah. I think it's a very accurate description, and it has taken a while. So Ian, how did things look from your side about getting to consistent and repeatable testing in the actual lab day-to-day work from the developer perspective?
Yeah, I mean, I would say that through our exercise, there were definitely some surprises. And I mean, a surprise is always good because that means you actually learned something. Right? So even in the case of exactly the same system under test, the same test equipment, which also comes from our company, right? It's still, some aspects were still challenging. And I think a lot of it stems also from the fact that the test plans themselves, in some cases, were not as crystal clear. And so at the end of the day, that's kind of one of the biggest learnings. And I'll cite one example is on the core. Right? We would say, oh, the core, I mean, at first we started with different cores, right? You have a different core, we have a different core. And that's not a big deal. We're just doing functional tests. We just get some KPIs. But guess what? The core ended up affecting the result. And because, again, we were measuring latency, and so obviously the latency of a registration of a UE, right, was highly affected by the core. But then to really have a test be reproducible, we can't enforce every lab in the world to use the same core or core emulator, right? So we needed to get to the point wherein what do we need to do on the test plan standpoint to make sure that this doesn't happen. And so through EANTC and Valor collaboration, we actually submitted some change requests to the specifications to make it much clearer that, hey, in your test equipment environment, you need to make sure that these aspects, don't affect your test, and here's some examples and here's some recommendations. So, and that's just one test, right? Out of a test spec that's now 235 pages. So we need help. But at the end of the day, I think that's kind of the exercise we're undergoing, so that at least at the end of the day, we can get to that reproducible test, which is important for again, gaining trust. Yeah.
Right, thank you. Yeah, and together with i14y, we are still at the starting stage, I would say. We haven't really run any similar tests between the labs yet. We have just worked a lot on test plans. And I think we've reached a good plateau there, thanks to your support and engagement. So what is your take on getting to the same level of testing comparability on the RIC and XApp RAP scene, Alicia?
So yes, for the RIC testing, we need to standardize everything. So the first one, we need to align on our test scenario. So we need to set up the same scenario, the number of the cells, the number of UVs, the UVs traffic patterns, and the UV movements path. And all of this, everything is need to standardize to the parameter that each other lab can use in the VIB scenario. So it is tend to ensure that the scenario runs and the RIC application receive the same data formats and have a same results that can ensuring the results can directly comparable across different labs.
Right, thank you. Yeah, and I'm sure we will see quite a number of challenges there in the test execution as well, because the number of parameters and variations in rig testing are even, at least comparable to the end-to-end testing, maybe even more complex. But the idea is to also provide some feedback to the SDO, to the test specification, and then to help the industry to make things more reproducible by describing it also for everybody. So we've already started talking about the challenges. So do you want to add something on the challenges, Ajesh, that we've seen in the Valor i14y lab, and what we can learn from them?
Okay, definitely. I think Jan already mentioned some challenges. Yeah. So whatever I said in the before question was it's all the ideal case, but it never happens every time. So many challenges. So we did, for this end-to-end testing, we did scrutinize this, some of our test specifications, and we selected a similar set of test cases, and which we are wanted to execute in this. So then after we start executing these test cases, and because we are not really comparing the results at the time of the executing, yeah. So we worked in a way that, okay, VLR does it independently, we do these testing independently, and after 1 or 2 months, we join into a call and we see how it's been done, yeah. Then we find, okay, you got for some test cases, you got much higher throughput, and we didn't get higher throughput, yeah. Then we sit and, scrutinize it, or find a root cause analysis, like why this exactly varies. Some had a more variation than 50%, right? And we really went into this, what went wrong. So most of the time we end up maybe that it's an RF attenuation issues or the configurations. For example, for one of the TCP test cases, I remember, right? You are getting much higher throughput, we are not getting so throughput, so then we scrutinize it. Okay, what went really wrong? So at the end, it could be the configurations of the windows or the configurations of the bandwidths, because we decided to run independently. Otherwise, it would be just copying of the campaigns, what you have already done and what we are doing. So it doesn't make sense. So we wanted to also analyze how the engineers interpret the specs, yeah? And we want to compare it. We want to know where exactly the gap is, because we wanted to contribute all this back to the society or the ecosystem for the standardization organizations to fix it. Yeah, because somebody has to test it. Otherwise, the specs will be there, and if nobody is really doing some real testing, and there is no opportunity to fill the gaps or clear the specs if something is there. Yeah, so this is how we did this activity.
Right. Yeah. Speaking about test specs, thank you, Ajesh, for bringing this up. So, Ian, you're a co-chair of the O-RAN Alliance Testing and Integration Focus Group, the TIFG. So, what do you think is the role of the O-RAN Alliance here? What can be done to support this topic from the standardization point of view?
Yeah, no, I think a organization like the O-RAN Alliance is critical, right? Because that's where the specs are open and everybody can see it, and then people can scrutinize it and execute it in their own labs, right? And so absolutely standardizing this is the most scalable way of truly enabling the whole ecosystem, right? And I have a fellow co-chair of TIFG there as well, PJ. Say hi, PJ. All right, so from DT. And our job is to make sure our specifications are solid. And in a way, it's kind of a, I'm in the position now of criticizing ourselves, right? And it's important, right? You need to have self-reflection and understand, okay, this industry over 3 decades, all this testing has been done and concentrated now in just a handful of really big companies, right? And we're in this start of this sea change of why don't we open that up? Why don't we allow more open labs to participate, more smaller vendors to participate? And it's a journey, right? We can't expect an overnight success. And I think, but we need an organization like O-RAN Alliance is, I think, the best place, to be honest, because again, you have the operators there, the vendors there, the test labs there, the OTICs there, and basically everybody in this ecosystem represented. So we want to see you participate and help us get there. And this exercise we did with 2 labs, right? We want to scale that out to more labs, right? And we scaled that out to more test equipment vendors, even to our friends in Keysight, right? We want them to be involved, right? It's not just about Viavi or Valor or i14y, right? I mean, in order for this to be a successful ecosystem, reproducibility needs to be achieved across any lab, around the world. So.
Yeah, definitely. But before we go to the community outreach, just one more question regarding standardization, because with i14y, we're basically working with the telecom infra project. I see also Abdel here from TIP, so hi. And so typically from the Oran Alliance, I know that we're doing standardization for product testing, for module testing, end-to-end integration. But now with the RIC and optimization, we're talking about the use case applications. And so we're also you providing feedback to TIP and contributing that test plan, right?
And yes, so within the TIP, the RIC testing is belonging to the TIP Open RAN via subgroup. And in this subgroup, they already defined 16 different scenarios about the RIC testing. So when the energy saving is belonging to the number of 9, and in this scenario, they focus on how well the RIC application save energy without harming the user experience. So when we conduct our test plan, we need to focus on the pass-fail criteria, not only the energy saving percentage, but also the user experience parameter, such as like the degradation of the throughput. So to ensure that the user experience that suffer the loss at all.
Right, thank you. And what do you think are the remaining gaps and the next steps for you?
We already have modeling such urban areas and traffic patterns across different labs. But to be honest, we need to build up the live topology and get the information from the real world. But the real world network is very complex because the traffic will go up and down constantly across time and location, and it will be directly affect the RIC application to the mechanism to tell about how to switch on or off. And so in our test plan, we still have missing something like the multi-band interference or such as like multiple slice configuration. So we think that we also need to get more material or define more complex parameters from the equipment, such as like VIV and some actual information like the actual device to build out a more realistic environment to testing the application.
Right, thank you. And I think there's going to be a lot of work coming, particularly for the use case definitions, because that's something the industry hasn't done so much yet on a standardization level. And I'm also happy to contribute there and to the TIP program, so just as a side note. So Ajesh, from the i14y perspective, what are the next steps and programs you are working on to improve the consistency and reproducibility?
Okay, so from i14y point of view, so we really want to become like a reference hub for reproducible results and repeatable testing. Not only just an end-to-end, we want to work with all the labs collaborating across the globe, doing this repeatable testing, and not just in the area of end-to-end. We wanted to explore what's happening in the RIC, what's happening in the other entities or other elements, and also we wanted to little more extend or expand this testing activities where we could put some more automation, strengthening our CI/CD platforms. And for example, it's just not between the labs as well, because it's inside i14y we have a bunch of engineers who are sitting behind the stage who made these all kind of things happen. So we want to expand this to other different areas of Open RAN, and also we wanted to have more labs added to this activity, or even I would say like some activities like passing the test or like kind of a round robin method where we pass on one device to be tested to the other labs, and let's see how the things are repeatable. Yeah. So this is, we wanted to really collaborate with more labs, expanding our all test areas.
Yeah. Exactly. I couldn't agree more. Thank you. And I would like to add, I mean, the platform testing is something that you and I don't do, but there are other consortium partners in the i14y lab who are also active on platform testing. It's not only the infrastructure and the applications, but also the cloud edge platforms and other platforms underneath. So, and of course, automation will help a lot, yes, because we're only a little more than a handful of engineers and we cannot do everything manually. So Ian, for some closing words, like what do you think are the next steps from your point of view?
Yeah, I'd like to plead, call to action really for the ecosystem, right? Like, imagine in 2 to 3 years, a network of trusted labs, right, around the world that operators are actually engaging with. That we get to a point where in an open testing lab where tests are conducted in a baseline manner, not operator specific, but it's enough that several operators will say, okay, that's a good blueprint, I trust those results, and now I'm going to offload some of my own testing to that, right? And that's hopefully our shared vision, our common vision. And we invite you to work with us, right? I mean, this is just a nugget of a collaboration. We can have myriad of pairs of labs really trying to make our tests more robust, right? There are now 20-something OTICs around the world in the ORAN Alliance, right? And there's a handful that are non-OTICs that are also doing a lot of these tests. So it's a plea to work together. We need the labs, we need the operators to provide us the feedback, and we need the vendors to come in and be willing to be a guinea pig. So if you're a mature vendor and you're almost certain that your test will pass, please volunteer your DUT, because then you will be the reference. You will be saying, look, we tested XYZ and it's reproducible across these labs, and you will be put in a very good light in front of operators. So that's our plea. Please work with us.
Yeah, thank you very much. I think I can't add any more. So we're working together with ORAN Alliance at i14y Lab, and of course also with TIP in different programs that are not competing with each other. And yeah, that was just a very quick intro from the machine room, what it takes to do consistent, repeatable testing, to grow the trust. So we're reaching out, we're building the trust with a lot of hard work from our side. We're not waiting for the operators to provide the trust upfront to us, or to whatever. So thanks very much for your attention, and I'll hand back to the moderation. Thank you very much.
Thank you all.
Thank you so much also from my part to all the speakers. Thank you for sharing your perspectives. And we are, of course, looking forward to meet the experts at our marketplace. So we are almost done with the first part of the conference, of the summit, and already almost arrived at our lunch break. So I'm the last woman standing between you and the lunch. I'm aware of my duties and opportunities, but now you should be hungry and eager to talk about what you have learned. We have you covered, of course, so enjoy your lunch, visit our marketplaces, as I already said, look around, discover, have fun with the networking, and of course, again, use the opportunity to participate in our interactive deep dive sessions. Remember, they're starting at 2 o'clock. And remember, there are two. One is taking place here at the main stage and the other one on the 5th floor. You'll find everything. And I'll see you again for the second part of the conference. Thank you. Hello and welcome back, dear guests. Now the second part of the summit is about to start, and I would say we should have a closer look at the results of the deep dive sessions and a nice recap. Monica, I'm handing over to you. The stage is yours.
Thank you. So for all the people who are interested in the topics which ran into parallel tracks, but were not able to attend those tracks, I will be here to provide you quick highlights what happened in those tracks. So if you want more details, you can go to the panel rounds and just speak with them directly. But let's go into this interesting deep dive sessions which happened. It really gave me much more insights. So first topic was applications in verticals. So where all Open RAN can be implemented in which vertical and not only like a traditional operator networks. So the topic was for Open RAN, private 5G vertical could be a good vertical, but here the challenges are adoption rate today is very limited. The deployment costs are still too high, and the business case is still unclear. And the companies want to stick to Wi-Fi and traditional networks. This is also due to some regional gaps in Europe, as Europe mostly has a smaller ecosystem. The new vertical, which could be interesting for Open RAN to use to a full extent, could be a military or defense section. As US is already testing it out, in Europe also we can test it out. We do already have all the available components. In Europe, the only thing now is someone like i14y lab to get everyone on board and put this testbed to live and give a proof of concepts that it will be a good fit for the military. Then the second session was evaluating the energy efficiency with open source tooling. Here, companies don't have to invest much more in knowing how much energy consumptions are possible and invest into a high-paying licenses tool. So this session discussed that you don't need to buy specific hardware, software, and pay licenses fee to start measuring the energy consumptions. You can probably use any server with Redfish IPMI and start measuring those energy consumptions via the open source Prometheus IPMI. Exporters without buying any license, remote PDUs, or additional softwares. With Kubernetes clusters, measuring this energy consumptions of each individual component and containers is possible. Yeah. Then there was a small description which was not discussed during this session, but you can go and speak with Jan further about it. At i14y Lab, we already used this 2 projects, and what was observed was that fitting this cluster size and the numbers of each server's CPU to the workload is probably more important than energy-saving options. Another key element building on top of this is shutting down the servers and rebalancing the workload can yield immense amount of potential energy savings. Last but not the least, utilizing the open source software like OpenTelemetry to trace each API and user inputs through the entire systems allowed to link the events in the amount of consumed energy to execute the tasks in each of the application with distributed infrastructure. So that was our second track on energy efficiency with open source tooling. Third track was how to accelerate open ORU innovations. So the main discussion was how we could modularize the hardware radio units. Till now, we have seen it in ODU, OCU, that everyone started using off-the-shelf servers, but not in the radio units. So with this, that's possible too. Also already showcased even RU software could be open sourced. For example, what Massive Beams tried to do with the OCP project is, on the hardware side, they have split between the power band related components and digital low power RF signal generations. Every RU on the M-plane side could be open source now, which is still missing, but OCP open source is trying to make this possible. And last but not the least, our fourth track was SMO in Open RAN. For this discussion was focused on the strategic importance of the Open RAN, where the operators are today for the Open RAN, and how portable is the portability of SMO standardization was debated. Testbeds and the labs are essential parts of building the trust and validating these solutions. In summary, SMO in Open RAN will hinge on balancing openness with practicality, ensuring the lab testings translates into development confidence and embedding AI at the core of SMO design. So that's it. For SMO in Open RAN, you can reach out to Abdel. I didn't have much of a time to get into more details, but please reach out to the sessions or panelists who were main in this interactive discussions, and they could help you deep dive further. So thank you so much.
Thank you so much, Monica. And well, yeah, welcome to the third block and back to future, as I would like to say at this point. We will look at the future of Open RAN and mobile communications, address topics such as AI and sustainability, energy efficiency, and automatization in the following panel talks. So let's have a closer look first with the next panel talk. We will have a closer look at open source in Open RAN. I would like to welcome my speakers on stage.
Hello. Hello. Welcome back. So this panel is about the future of open source in Open RAN. We already heard before that that might be an interesting topic. So we decided to have a panel discussing a bit what all of the details here are. There's one important point that sets this panel apart from all of the others. We do not have an operator on stage, which is interesting, no? I wonder why. So I want to start this panel basically with giving my two panelists, Tim and Andre, the chance to introduce themselves and maybe to say a few words about like why is open source in ORAN an interesting thing for you. Maybe Tim, you want to start?
Yeah, sure. Good afternoon, everybody. Yeah, I'm working at SUSE. For those of you who don't know who we are one of the, it's probably fair to say we're one of the 3 pure open source companies in the market. The other 2 are maybe a little bit more famous for various reasons. Red Hat because they are the bigger company, and Canonical because everybody uses Ubuntu. If that's why you know them, I would recommend you to take a look at OpenSUSE, which is actually also a quite nice and free operating system. But the fun fact is actually that we are the oldest of the 3 companies. So we've been in the market for 1 year longer than Red Hat exists. So we were kind of the first ones having the idea that there is a need for a company that helps people use open source in a reliable way, also for enterprise use case. And that's basically what we do. We're not selling our software. The software is free, but what we are selling is we are selling sort of the necessary help that is required in order to use open source software, for example, in telecommunication networks or for any other business critical use case where it's about making sure services are reliable, secure, and all these things. Yeah. Why is open source important in the context of Open RAN? I think in order to not sort of get ahead of what we are discussing later on, I'm going to make it really simple. There is no Open RAN without open source. You literally cannot run Open RAN without open source because the minimum you need is a server with an operating system on it. And I mean, I'm not sure if anyone has ever tried, but I wouldn't recommend running Open RAN on a Windows operating system. It's probably doable, but I don't think anyone is seriously considering to do that for real. So, I mean, there you have it, right? Like without open source, there is no Open RAN, basically.
Thank you. It's a pretty good take, I guess. Andre, you want to continue here?
Yes. So I'm Andre. I'm with Software Radio Systems, or short SRS. So we are the company behind SRS RAN, formerly known as SRS LTE. So we are also a true open source company. So since the inception over a decade ago, so we've been focusing on building RAN software, and then open sourcing that software in 4G. So we've done the UE actually as well. So a software stack for the UE and the RAN. But with 5G, we kind of went a different approach in which we are, going more, focusing more on widespread and then focusing on the RAN here. And we did a kind of a radical step about 4 years ago where we, based on our knowledge of implementing a 5G prototype solution on our 4G stack, which was very successful, a DARPA-funded project actually where we extended the UE and the eNote B 5G NSA and SA. But the biggest learning from that is that it's actually quite complex and not ideal to use an existing 4G stack and then building 5G on top. And to get all the benefits from 5G and then from the disaggregation and from all the promised benefits. We kind of said, okay, we are going to design a new architecture from scratch, embracing all the all-RAN, all the 3GP interfaces, and that's what we have today as RAN 5G. And that's totally open source on an OSI approved license, that is what we are talking about today, no?
Yeah, I think so. I think it's one very important piece of the software that you need to run your ORAN. So when we talk about all the different software pieces that you need to run ORAN, and also looking back at the summit of last year we had a session about OCloud, and the very interesting, there were a couple of very interesting takes. There's like, you need somehow this OCloud thing, right? If you want to run all of your workloads, you need something below that, so you might need that. And so what is this, what is your take, Tim, on this like open source OCloud part? I think there's like one project, at least that I saw, that comes to mind, like Silva. We discussed that very vaguely last year, but I think Tim would be a very good candidate here to give us a bit more of a background. Where's this going?
Yeah, so Project Silva, for those of you who don't know it, is basically a project that aims to develop a common blueprint for a telco cloud solution purely based on open source and in a vendor-neutral way. It was originally started by 5 European operators teaming up, Deutsche Telekom, Orange, Telecom Italia, Telefonica, and Vodafone. They invited Ericsson and Nokia to be part of the founding group, and then SUSE joined a little bit later to sort of cover off the open source aspects of the stack. The project has been quite successful in developing a running stack, a workable stack, and that's actually one key differentiator this project has versus a few of the other initiatives that have existed in parallel and previously. So there is a strong focus on making sure that the stack is actually usable, that the software always runs, it is actually being used in a couple of the participating operators in production today. And it is, the intention with Silva is to build a horizontal cloud stack, which basically means it should be able to support any telco cloud use case, any telco application, from packet core. OSS, BSS is usually not that much of a challenge, but of course also for the RAN. Like RAN has been a specific focus of the last couple of releases in Silva, and we have done a couple of contributions to that end as well, contributing our experience stemming from some of the collaborations we have with our RAN and ORAN partners. So the stack is getting quite close to being ready for RAN scenarios, both from a runtime point of view, in the sense of having, for example, a real-time kernel option available in the operating system, having configuration templates for the Kubernetes layer that are able to accommodate RAN workloads on top, but then also from a management stack point of view, we are using Cluster API and Metal Cube for bare metal automation, so that we can also zero-touch deploy and lifecycle manage the software stack in a RAN use case, because that's an important characteristic of a RAN scenario, that you don't want to have qualified staff on site having to do manual interaction with the physical hardware. So I would say, all in all, Silva can be looked at as an OCloud. But it's of course not only an OCloud, it supports other telco cloud use cases as well, but there is all the necessary ingredients are there so that it can feature as an OCloud if that's what's required for a given use case.
Yeah, thank you. One thing that is interesting about Silva is that it's not a project where a lot of software has been newly invented, right? So Silva is like, it's a group of people and consortium that reuse software that is already there in open source. It reuses Linux, Kubernetes, all of these things that you talked about, the bare metal orchestrator, stuff like that. But then when it actually comes to ORAN, and that's something maybe more of a question to you, we need to put the workload on top of that, right? We would put some CU, DU, whatever else on top of that. And that's something that might not be naturally coming as an open source solution, because I have the feeling a bunch of companies have been earning quite some money with not providing this as open source for quite some time. So interesting decision from SRS to go into this direction. Do you think we'll see more in the future there, or?
More from us, definitely. So yeah, I mean, we all in with this, and we see a clear opportunity. But I mean, historically speaking, I guess the reason why this has not been the case with Silver or other similar platforms is probably because the lower hanging fruit is in the core and other elements, and not so much in the RAN, which has its challenges with the, you know, with the DU and the timings and all those kind of things. So it's good to start slow and go with that. But yes, in general, it's a good thing. And with ORAN, obviously, with all the specifications that are open, it's an enabler for companies or projects in general to write telco code, right? And then this has not been the case before. And then if there was if it wasn't for the open frontal interface, for example. And that's something that we always suffered in a way in 4G, that it was not possible. Even though we had the technology, we could not you know, interface with a commercial radio unit, right? And that's something that ORAN brought, and with the open frontal, and then which others are also doing. And then I think there's more projects coming, more companies doing that, or more projects, groups gathering. But obviously, it's not ideal, the state that we're currently having. One issue that I see is the adoption of that. So yes, we are an open source project, but also the company behind the project is contributing 99% of the code. So in an ideal way, an open source project would see adoption, community adoption. There would be a combined effort, right? And that's, I think, something that we would like to move towards. And there are a few challenges to solve still, especially looking at the telco industry and then their IPs and then all those kind of topics. But that would be interesting, and I see things changing there. Yeah.
Yeah, I think like you made a very, very important point about the adoption of open source in telco, and I think like one of the main blocking things there, usually, at least what I've heard through the years, is who's responsible for all of that stuff? Because I'm now consuming open source code, so who can I sue if this goes wrong, basically? So what's your opinion there? Like, who's responsible when we build this whole open source stack, or who should be responsible in the future if we build it just on open source or with more open source in it?
So, I mean, if you look at it from the viewpoint of building a radio access network with open source components, I don't think there is an actual difference in that situation compared to a more traditional approach. Ultimately, the operator is always responsible for the outcome. And that has always been the case. If you look at regulatory obligations or security obligations, like if you just look at, for example, the Cyber Resilience Act that's coming out, which categorizes mobile radio networks as critical infrastructure, the operator is responsible for making sure that those services are available. The question is how much of that responsibility can be delegated to others, and what's the relationship between the different companies that are involved in building the system technically. Traditionally, there has been quite a lot of responsibility transfer to sort of the vendors that are in the background. In a disaggregated scenario, that balance obviously shifts a little bit. But there are, for example, still situations where the overall integration responsibility, for example, gets outsourced to a systems integrator instead of being with the company that actually sort of commercially operates the network. So like disaggregation and openness doesn't necessarily mean that the operator has a significantly different piece of the pie, so to say, from a responsibility point of view. But at the end of the day, somebody needs to make sure things work together. And one of the key benefits that disaggregation and breaking things up into open components has is that the sort of the secret knowledge that is required to make such a system run becomes more and more commoditized, like because there is a larger set of people that get exposed to that type of knowledge, and so simply the group of people that have the necessary knowledge to make it work grows over time. It's not as concentrated in small groups that work for particular companies anymore, and I think that benefits the whole industry to a very great extent. And if you look at how far ORAN has come over the last like 5, 6, 7, 8 years, you can see that there is significantly more knowledge available in general through documentation, conference talks and everything to make things run. So it's not as secret anymore how to make things run as it used to be.
I think this is probably a good take from a larger system integrator in the end, or Linux distributor, right? But if we look at like a bit of a smaller player in the market, like Andre, do you like think you want to have a system integrator between what you do and what you sell, or how do you see this?
Yeah, I mean, definitely. I mean, we see it in a similar way. So us being like a pure COD software vendor, we definitely lead like a system integrator which takes the responsibility of building the end-to-end system and makes sure everything, selects the components, makes sure everything works together. Ideally, obviously, we pre-test and give suggestions, but it's up to the system integrator with the end customer to kind of ensure that. But yes, the knowledge and the learning curve is very steep, and again, the disaggregation and all the interfaces and all the like possible things that are that can be changed and can go wrong. The attack surface, so to speak, is great. Is larger than in a completely co-located and single vendor system, and so this knowledge transfer needs to happen. But at the same time, you're also benefiting a lot from open source, from all the lessons learned from data. From open source, from the infrastructure that is already a commodity in data centers, right? So why not also adopt that in the RAN? And I think that that will happen, and that we are on the right track as an industry. I mean, we discussed this. Like, we can also see that from the incumbents actually adopting the same ideas aspects. So we can't be that wrong, right? So they're also going away from building appliances and everything's virtual and everything is using open source technologies and so this is a good thing. But yes, we need someone, to come back to your question, who kind of selects the components, manages and does the integration together with the customer and then to deliver a successful product.
So taking both of those aspects is, for me, is going a bit in the direction of like asking for more system integrators, bigger system integrators, specific system integrators. And on the other end might be more of pushing a bit of the responsibility to the actual operator in the end. Is there something where the communities that run these open source projects, or the telcos, operators, whatever they want to use them, can find some middle ground to just work better with each other? Is there anything where you think like this is a thing that can be improved in this interaction here?
I mean, for us, we see that more and more traditional system integrators who have traditionally worked with the incumbents and basically, to be honest, they were not really system integrators. They were buying something and they were basically giving and installing it at the customer side. And so they're now perhaps becoming more system integrators because they're seeing in the tenders and the RFIs that Open RAN is being requested, and so they need to embrace it and need to build up that knowledge. It's challenging, but that is the case. At least this is like the trend that we are seeing on for that.
Yeah, and the other thing is that I think with everything the O-RAN Alliance and the O-RAN movement in general has done, there is a vastly increased understanding of how to make things work across the industry. So by virtue of more people having the necessary knowledge and the software ecosystem becoming more used to the specific requirements of RAN, of supporting RAN workloads and making the whole system work, the integration effort also goes down over time. I think we can clearly observe a trend towards all the different components being better prepared to work with each other. The example that I always point to is that the capabilities of supporting real-time applications in the Linux kernel, they were a little bit of a corner project for quite some time, a separate patch set that needed to apply on top of the mainline kernel code base, and then you had to recompile everything. You couldn't actually compile it exactly the same way. You needed to change your compiler flags a little bit and all that. that is no longer the case as of last year. The patch has been integrated into the mainline code base. So, and that is partly due to, I would say, the pressure of the ORAN movement towards the Linux kernel to sort of to accommodate these use cases better. And you can take this as an example of something that sort of improves the overall ecosystem to a degree where the sort of the bar you have to jump over in order to make things work isn't as high anymore. It's coming down gradually, step by step.
Yeah, I think it's a very good comparison with this kernel patch. That was handed over on paper to Linus.
Yeah, that was
very cool shot.
It was a little ceremony in the Open Source Summit in Vienna last year.
It took forever to get that merged. Yeah. Switching topics a bit, and that's really something. Like 2 weeks ago, I was on the Open Source Summit in Amsterdam, and one of the biggest headlines there was really digital sovereignty. So really talking about how can we use open source software to support this vision of becoming more independent, more self-sustaining, all of those things. What are your views on which role does open source software play here? Is like multi-vendor, is that our solution? Is open source the solution? Where are we going here? Maybe whoever wants to start.
I mean, there's little debate between us, I guess, as a open source companies. Of course, yeah. I mean, we need that, and we need that ability to inspect the code, to have that transparency, and you know, to obviously also have it in Europe under control. And then open source is a key. Is a key ingredient for that, and the same applies to security. Obviously, this is also an important aspect. So we need to have like that ability to kind of have robust algorithms and not have security by obscuring things and all those kind of things that play a crucial role for us anyway, and they're key to achieve that sovereignty. In Europe and obviously also across the Atlantic, it's the same. So they are, our friends there are following the same policy there, and this is clear from our perspective.
I mean, I couldn't agree more. I mean, at the end of the day, I think it's as simple as this. Open source is the ultimate form of digital sovereignty at the end of the day, right? If the source code is open, if there is a community project that has not only the ability to maintain the code, but also build the code, and there is a diverse group of maintainers looking after the code, that is what true digital sovereignty is about, right? Digital sovereignty is not about guaranteeing if a software company from the US makes a contract to provide government IT in a European country and then storing a copy of the code, of the source code in that country, so that if something happens to the mother country, they could still sort of take fate into their own hands and continue doing things, right? Because everybody knows that it takes more than just having the source code available to sort of continue running a given piece of software on your own if you are used to only using it previously, right? It's that you need an actual project that is built along the lines of how open source communities work today in order to make that fly.
And one thing, just to add, that just came to my mind where you're saying with the binaries. I mean, that basically what is the counter example, right? So if you're just shipping a binary to someone, not knowing what's going on there and what code has been compiled. So we've been getting, and we've been involved in creating just very recently, like very detailed software bill of materials of our builds, because customers require that. So for each and every build, you can not only look at the code, you can not only get the pipeline of how this could be built, but for all the images, all the container images, you have a detailed list of the components that went in, the compilers that were used, all the libraries. So whenever there's a security breach or a bug or whatever, you can automatically see that your binaries might be affected, and then trace that back. And that is also very important, that traceability, so to the source. And then there's no way to have that basically without open source. Obviously, you can also have an SBOM for binary, but ultimately you want to have a look at the code, right?
I think those are very, very good takes. There was there was one important thing for me to learn at the Open Source Summit about open source, because there was somebody on the stage in a keynote, and the question was going along the lines of, do we need more European open source with European like digital sovereignty? And the very simple answer was, there is no European open source. Open source is not European or American or whatever else. The whole idea is that the code is shared and you can look at it. And I think it's a very interesting take when talking about sovereignty and not just European. So to wrap this up, because I already see like red numbers there, I hope I'm not getting kicked off the stage. One last thing, looking at the actual future of open source in Open RAN, like in 1 or 2 sentences, what do you think is going to happen with open source in this context in the next year?
So, I mean, I hope that things are continuing along the lines of what's happening right now, right? Because right now, I think that we are at a bit of an inflection point. I think, for example, through projects like Silva, we are starting to see that there is indeed a full open source based stack available. It's possible to set it up and to make it run. And my personal perception is that also the big vendors are more and more embracing these patterns, not necessarily in the sense of open sourcing their code, but to adopt the operational paradigms that come along with it, and also to realize that at least the underpinnings in terms of OCloud and everything is something that is best done as a community effort, because it's at the end of the day based on the same technologies anyway, Linux, Kubernetes, and so on.
Yeah, and on the RAN side, I mean, we've all heard those, bad news about ORAN, and then luckily, I mean, interestingly, like those ORAN deployments, I mean, they have been using RAN software that was not open source, and my hope and my wish is that we are actually taking that as a chance and then to continue that, but with real open source CDU. And we have a very aggressive and strong timeline. So when you're asking about and commitments, when you're asking about the future, it's bright for us, and so it is for the open source community. And yes, I believe in that. And again, so we are continuing our collaboration there, and also with Project Silva, continuing that and like our goal is here to have a full end-to-end system RAN, not only RAN, but also a full end-to-end open RAN system based on open source technology that is actually deployable. And that's the key thing, so that that can really be considered, that goes through all the testing that is available, hopefully can be extended and finally be proven to be successful.
Those are wonderful lines to end on. Thank you so much.
Thank you to the panel for this insightful talk. Thank you very much. And now we're switching to the next future topic of importance, AI, and the AI role in Open RAN, actually. So I would like to welcome on stage the next panel.
So welcome, everyone. Let's go. What, you want to shake hands? Oh, we haven't seen Frankie. Yeah, exactly. Exactly. So great to have you guys here. I think we should clarify, at least when we talk about AI, we do not only talk about large language models, but we actually also talk about classical machine learning. Think about hidden Markov chains, Kalman filters, and tables and Markov chains and whatnot, particularly as you go down the stack. So when you see AI, I think just in your mind, it's not only AI in sort of the hype sense where you get money, but it's actually also about machine learning. With that, let's introduce our key experts, because I really think I've talked enough today. Let's get a kind of very quick introduction from each of you, maybe starting with Franco. And maybe when you introduce yourself, just mention one of the key things either you or your company has been doing in the area of AI and RAN. Okay. Frankie?
So Frankie Garcia from Keysight Technologies. We're a test and measurement company I work for the 6G Advanced Research Group, and we're very involved in ORAN and the ARAN Alliance, the ARAN Alliance. So a couple of things that we've been doing, 2 examples at extreme levels of the AI spectrum. One is introducing AI natively into the physical layer, and that is being done jointly with NVIDIA, where we've got this platform that essentially surrounds a radio unit with a channel emulator, an RF UE simulator, and an ODU emulator. And we essentially transmit over this radio unit real conformant and standardized 5G signals. We take the IQ out of the open front hall and we feed it to a massive GPU from NVIDIA, which has wings. Honestly, it has wings. And they are then developing their AI on top of that to build this neural receiver. And we could therefore benchmark it, profile it, test it, building scenarios into the channel emulator, bring them from third parties, etc., and really push the development of an AI and test it and so on as a neural receiver. That's at the low level. At the high level, it's one of the demos that we have here. We're now using a digital twin. The digital twin we wanted to use because there isn't big ORAN networks out there. And one of the things that we wanted to explore is the ability to do anomaly detection over cellular networks. And in particular, the most common problems that you have with PCI conflict, RSI conflict, and handover issues. We can simulate all of that with our digital twin that we have called RigTest. And then we've developed a framework to extract those KPIs, connecting it to FlexRig over the E2 interface, train the model offline, etc., and then bring it back to the digital twin environment to see if it actually works and connect those things. So that's an AI for RAN. What's interesting about that, and I think you like this, is that the actual application that does the anomaly detection no longer interacts with FlexRig. It doesn't need the E2 interface. It runs off the database or what would be the telecom provider's data lake.
Super. Christian?
So, Christian Gabachak, I'm a solution architect manager responsible for our telco engagements in the EMEA region. So, briefly introducing NVIDIA, I think everyone by now knows what NVIDIA does, but I know that 3, even 5 years ago, we had to go to telcos and explain them that we don't do only GPUs for gaming. It was a very hard time at that point. So now, as you can see, parallel computing and accelerated processing is what everyone is looking after, right? Telcos want to improve the costs and the operations of their infrastructure and the learnings from the data centers, not only gaming, but from the supercomputing actually gives you those wings that you mentioned earlier to accelerate many of those new workloads that also help bring innovation and future solutions today, like to telcos, right? We participate also, like we are platform developer, which means that we are building this hardware and software stack for the partners like Keysight, so that they can solve their problems for customers, and or Tieto, who actually integrates all this for customers, and many others. We are relatively open how we provide our platform, so everyone can use it depending on their needs, right? So that's what we do basically, and I cannot stress it more. We develop full software stack with everybody to make sure that whatever the innovation is, we are open to participate in the projects like AI RAN, Open RAN, Silva. We are actively participating in the projects that actually perpetuate growth of those innovations in the future.
Cool.
Right.
Mikael?
Yeah, my name is Mikael Pedersen. I'm with Tieto area, and I'm a global principal for telecommunication. I think Christian already kind of mentioned that we do a lot of integration work, but generally professional services. I guess for RAN, and in this context, I think a lot of the work we do is maybe not directly AI related. We use AI for optimizing algorithms, so again, looking at the lower levels of the stack. We found that AI can be a good tool to kind of help figure out where can we potentially improve the existing algorithms using AI itself. maybe not ideal, and especially not if AI is considered LLMs, but I think you came up with the disclaimer early on, so I think we're good to clarify that work. In addition, we're also been working a bit with some solutions for again simulation, testing, log analysis, and abnormality detection. And for all of those, we utilize AI or at least machine learning concepts as well to kind of sift through data and come up with some decisions that would otherwise be difficult to maybe achieve.
Right. Right, so it's really exciting, and of course we've seen sort of the common denominator is really actually using the NVIDIA computing platform and then working together actually across companies, which I find really exciting. Now, I think the last couple of days we could almost forget that there is something called legacy and existing networks around, right? Because we are really talking about probably some of the most advanced stuff currently, and certainly also even more advanced as we go into the future. But how do you guys see what we can do with existing legacy and let's say the next couple of years in 5G? And maybe then first with you, Michael, and then go towards Frankie.
Sure. I think where we are right now, I think it would be good to kind of repeat the whole algorithms and improvements we're able to get from that perspective. But as we move closer towards like 6G, and I think a lot of that is kind of aimed at again, the IoT, machine-to-machine, and critical communication as well. One thing that I think hasn't really been discussed too much is like the whole orchestration and workload placement and trying to optimize those, and especially when we're moving closer to the edge. All of a sudden there's quite a big optimization problem there as well with where does it make sense to place your workload, both in terms of costs, performance, and requirements from the applications themselves. And I think that's one of the places where I think we're kind of figuring out AI might play a big role there, because it can take an almost arbitrary number of parameters in there, sift through them, and help get to the decision. I'm not saying AI is going to replace any existing experts, but I think it's going to be a tool that will definitely be of great value for anyone working in these areas.
Right. Michael, just a quick follow-up to you. When you talk about the edge, what edge are you talking about? Where are you in the stack?
I'm talking about the RAN, so we're talking about like the smallest amount of compute that's right furthest towards, I guess, the cloud, but still in the telco space.
Right. Okay. Thank you, Christian.
Yeah, I really like the question, because it shows how you can actually approach real problems, and we have many telcos actually facing the same problems when they try to innovate or optimize their infrastructure across the regions. So from my perspective, and I'm very technical, and sorry if I bore people around that, but NVIDIA provides like a full stack, what I mentioned earlier. What that means, that we work heavily on building the hardware, accelerated hardware, building the software that enables you to use this hardware in various ways. So virtualized RAN as an application, right? AI for RAN, as a part of AI RAN Alliance, yeah? Digital twinning, and SMO, which utilize AI models to actually optimize operations in the real time to reduce the cost of the operation of the entire infrastructures. So when you look at this stack, what we provide is a very disaggregated set of tools and tools and frameworks that our partners can take and put them to work in the place that it's really necessary. And it also means that you can choose the components that are critical for the operation. You don't have to buy into the entire stack down to top. And it's very important for many telcos who try to revamp their infrastructure, but at the same time they want to use, for example, innovative SMO with a traditional, maybe RAN sites. So they still want to reap benefits of some of those solutions. So I find this disaggregation and openness of the platform crucial in this endeavor.
So if I hear you right, well, you don't have to wait for 6G in order to actually use NVIDIA, but you can already deploy it today, right?
Right. 6G is another topic which brings a lot of innovation, and that's where actually NVIDIA platforms shows the most of potential, will show the most of the potential. That's what we foresee. But at the same time, currently, you can already start using some of the frameworks, integrate them, and this is exactly what our partners are doing right now.
So Frankie, over to you.
So yeah, I will add to my colleagues. So what is 6G today, right? You can't touch it, you can't feel it, it doesn't exist. I think recently we've published the first physical layer, right? Without that, you can't move upwards, right? So what are we doing today? We're using 5G technology, we're using O-RAN technology to look about the future of 6G, which is all about AI. And we're using these technologies to drive the inclusion of native AI all the way from PHY to application layers, using 5G technologies and O-RAN technologies, right? And then on top of that, we're looking at AI to manage those services and including, you know, with the cloud edge continuum, if you kind of look at a lot of the European research projects that are establishing out, the cognitive planes and so on, and the orchestration that might lead to use that RAN to be used as supporting AI use cases. So we're actually evolving 6G through existing technologies and existing services, I would say.
Yeah. No, I think that's an important thing to say, right? It doesn't mean that this is something that becomes relevant in the next couple of years, but this is something that is relevant even today and will continue to be increasingly more relevant, as we've seen last couple of days. So maybe over to you, Christian. So if I take a look at sort of your product portfolio, particularly on the hardware side, and I must admit, I was maybe a bit naive. Initially, I thought, well, you know, NVIDIA is all about fantastic compute capabilities, but super energy consuming. So initially I had a kind of idea, yes, you might use it to try to save power in the RAN, but at the same time you're probably spending even more to compute the large AI model. I'm putting things a bit on the extreme, and I know that because I took the effort to go through your product portfolio and see that you have many different solutions that are tailored to the workload that you want to address. But I suppose this is something that you're often challenged about, is the power consumption, right? And how to deal with that versus the goal of actually optimizing energy in RAN.
Yeah, that's true. So talking specifically about NVIDIA platform and how we present it also through AI RAN Alliance, how we try to build the adoption of this hardware infrastructure. There is obviously a big misconception that that NVIDIA compute hardware is very power hungry. It's always correlated with those huge servers.
It is also power.
It can be power hungry if you need it for a reason, right? For a good reasons. But generally, the goal of parallel processing and the reason why NVIDIA is successful is not that we produce very power-hungry compute, is that we produce very power-efficient compute. So that's actually what brought us significantly above any other providers of parallel processing equipment solutions. So we are very good in optimizing, in fact. And the reasons that in data center you see everything clamped together with a lot of compute in one place is also the effect of this optimization for specific use case, right? However, as you look at what we are working on with AI RAN Alliance and other partners that actually building the entire RAN stack on top of NVIDIA platform, they are also utilizing those solutions that you mentioned that are less power hungry, more adapted for distributed or even coverage RAN sites with Grace CPU, ARM CPU only, or Grace plus a smaller GPU combinations. So these are the options that are still, we plan to make them available. That's how we are working together with our partners on. So it's not, I definitely want to dismantle this, that we focus on consuming as much power as it can.
So, Mikael, I think as an integrator, I think you might be well positioned to tell us, or give us an idea about where are the biggest challenges in the Open RAN stack or the Open RAN architecture or anything in RAN where you see this could become complicated, this is already complicated? Where is the biggest challenges we should look for?
I think I already kind of mentioned like the lower levels as well, where again, it's good enough that we can throw GPU power and CPU power and do a lot of processing, but we don't really have the time to do that at that level.
So there's a time scales of a millisecond to microseconds.
Exactly. We can utilize AI, but AI is not going to be the decision maker here. I think then we'll try to utilize AI to optimize algorithms and then let the algorithm do the job. And then if we move further up, so again, if we're talking RAPs and SMO, I think we're getting into the time scaling where it makes sense to consider, makes sense to consider AI and more of the heavy lifting as well, because you have a little more time to deal with. But at the same time, we're still back to like efficiency versus gain as well. So spending all of these resources in processing, it needs to prove worth the extra cost that you're spending at those levels as well.
Yeah.
And I think just to add a little bit, and I think this goes into like the digital twins, and you mentioned using GPUs for gaming as well, where I think that level where you're doing simulation, I think that's where it gets really interesting, because again, gaming, ray tracing, you used it for light, now we're gonna use it to do propagation and modeling of radio signals as well. And I think to me, that's very interesting and something I think will be beneficial, not just now, but very much so with 6G.
Yeah, Frankie? Sorry.
Yeah, I would agree with what my colleagues have said here. I mean, we're using GPUs as a test and mentioned companies, so we're not building DUs, we're not building radio units, but we are testing them, we're building simulators, emulators, digital twins.
Yeah.
So if I look at what you just said about ray tracing, scenarios that you could bring in about the environment, all that kind of stuff, and you're entering a 3D modeling space that's equivalent to gaming, and at that point you need GPUs. Equally, if you want to try and play around with AI to manage all that kind of stuff, you need to do, especially deep neural networks, etc. You need to do lots of parallel computations of matrices that GPUs come in very handy. So to help build those digital twins, at that level, obviously there are very different types of network digital twins that might not need it, but at that level, I don't think you can get away necessarily from not using a GPU if you want to provide real-time feedback.
So Christian, is this something NVIDIA can solve? That you can be able to do sort of more advanced calculations at the microsecond level?
Exactly. So this is a great point. We do a lot of research on improving the spectral efficiency. So this is where we see actually potential of using AI in various of the scenarios. And whether it's microsecond or millisecond really depends on the use case. So we presented a lot of those examples, how actually using AI and parallel processing can improve spectral efficiency significantly, 20–30% just by optimizing the coding for specific scenarios, or we do the research in packet scheduling that will be fully accelerated on GPU, and low latency, ultra low latency enabler, which will be basically the key for scenarios like massive MIMO, where you automatically schedule hundreds of packets or thousands of packets in 1 second, right? So these are the things that suddenly will consume more and more of this GPU power or parallel processing. But very important thing is that when you look at the radio station, radio side, actually the majority of the power is consumed by the radio itself, right? That's basically what you want to save in the first place.
Correct.
So adding some amount of compute to that does more of calculation in lower latencies by saving significant amount of the spectrum is definitely a good choice, right, at the end.
So as we sort of are at the end, I think it's appropriate to start moving maybe towards something that could be 6G. For the ones who know me, there's a joke. And one of the things I have looked actually quite into detail on over the last couple of weeks is if I look at AI RAN, so thinking about how much of AI can you embed into the hardware, distribute intelligence across the stack, it's difficult for me to see the same architectural structure as we have today with ORAN. And in fact, I would maybe be so provocative to say that there might be elements in the ORAN stack that might not be necessary if you would go to what I call embedded AI in hardware or AI RAN. I wonder what your perspective is. Probably the most I could have asked Christian, but I will start with you, Mikael, and then we take it. I know you are burning for answering this. So maybe we do Mikael, Frankie, and then Christian.
Sure. Well, I think we've kind of touched upon it, and I think it's a lot of it is probably the whole RIC, RApps, XApps that are currently like separate entities as well, where I think there might be a room for it, but if it's gonna exist in the same way it does now, I'm not entirely sure. I think AI is still gonna be a big part of RAN one way or the other, and not just, I guess, the processing in there, but again also infrastructure, scheduling, broader network. I don't think we're gonna see like AI taking over the entire operation, so we're still gonna need the experts, we're still gonna need the operators that know what they're doing. But to me, I think it's a tool you can apply selectively and gain benefits. And I guess as your continuing development as well, I think there might be new areas where all of a sudden AI becomes relevant.
Yeah. Good, Frankie.
So yeah, it's an interesting philosophical question. And if you kind of think about it, we've got this open RAN architecture, then we allow third parties then to build XApps or DApps to take control of network functions, right? If you start introducing intelligent AI into that layer, do you need those XApps and those DApps anymore? So that's something that I think will change. The challenge is, if we kind of think about this, and maybe I don't think it's been mentioned yet in this 2 days or 3 days, is that with cellular networks up until now, we have specified every single bit that gets transmitted over the air to exhaust him.
That's a good point.
We don't, how the hell do we do that with an AI?
Yeah.
And hence that for us as a test and measurement company brings in very interesting challenges, because we got to take our simulators, emulators, test environment to a very different playing field, which I don't think we have the full answer for, but it is how to justify that an AI is doing the right thing, right? And there are lots of issues in there, which I'm not going to expand on now.
Definitely. Christian.
Amazing. So I heard a lot of great stuff about how you can actually accelerate bits of pieces where actually it makes sense and where it doesn't make sense. And it's all true, because there will be still some components that are simply great as they are programmed in manual, where there are components where actually using machine learning or advanced transformers will be actually bringing more benefits. And we will need then system integrators and developers actually putting this together and adapting those machine learning models as we go, right? Because the great thing about what I think we do is that we provide the platform. How you use this platform is really depending on where you deploy and who is deploying it, right? So if we see that Open RAN has a great footing in some scenarios, then what you want to do is actually you want to disaggregate each of those components. And NVIDIA, of course, NVIDIA platform enables you to do it so much so. Disaggregate each of those components, as mentioned earlier, bring them to sites, to fields, and optimize them for specific use cases, right?
Yeah.
So, yeah, that would be
No, and I think that's probably one of the biggest takeaways here. I mean, I don't think we should be sad that architectural components disappear from our stack, because that's happened all the life cycles we have been through. Things has disappeared, come back, or been redefined in something else. So I think this is definitely a lesson to take away, that AI is already here. It is being used. We are not it's not an academical exercise for going towards 6G. Well, it is too, but it is actually being applied today, and we will see more and more of it in an intelligent way, where we go in and evaluate. And I think, Christian, you said something that I think we all should remember. There are actually mechanisms and calculations that's happening in our RAN stack today that are perfectly fine. I mean, of course, I guess you could throw AI at it, but why would you? That might not be where you want to spend your effort. And again, coming back to just because you can do a thing doesn't necessarily mean it makes sense to do it. And I think that's maybe also an important takeaway. We are a little bit over time, just 2 minutes, which I think still is pretty okay. So as nobody is screaming at me, I think we'll just we're just cheating here and say, I just want one prediction from each of you, sort of say by 2035, where are we with RAN? And you don't need to, if it's ORAN, it's fine. It's probably ORAN in some form or something, but just one, and relatively short, I guess, or they will start screaming.
So, yeah, I'm not sure if it's a prediction, but I think we're on a learning curve about where AI is applicable and how we should use it. And I think with time, we will get better at this. And we won't be thinking, just use generative AI and large language models to solve every problem. So I'm hoping we do that. So it's not necessarily a prediction. I just think that we're at the beginning of the AI chain, at least as it applies to cellular technologies and RAN and core networks. And we're beginning to play, thanks to open source, open ORAN, the existing networks and so on, that we can play with that AI and learn how to utilize it better and better and better. So that's my prediction. I think we'll get better at it.
Christian, prediction.
Yeah, so I'm not good in predictions, but what actually we already keep on seeing, is that a lot of research that is being done around using AI not to replace the existing and well-established solutions, but oftentimes about adding new solutions or new components that improve spectral efficiency, like AI for code encoding, uplink, downlink, encoding, decoding. So AI for neural transmissions. So there are things that might not even happen in 6G, might happen later on. Yeah. But when you use AI, already start using it, you see benefits where they really due to and where it's worth applying them for. So what I would see is that
this is a yellow flag or
yes,
red flag.
that we will have this cloud native and AI native infrastructure that becomes more and more prevalent, because this will enable then innovating on those sites faster and faster. So that's kind of where I would see the huge benefit of that, right?
Let's see. Michael is a fellow Dane, so he has just one prediction.
I'll try to be quick. I think, again, looking back 10 years as well, people are doing things in bare metal, then virtual machines, now cloud. CPUs have improved, people have used accelerators, now we're using AI, and with the amount of money that NVIDIA has to develop new things, let's see what happens in 5 to 10 years. I think there's gonna be things happening between now and then. Maybe.
There are predictions. Yeah. There are things that we are not aware people are developing. So
yeah.
Exactly. Thank you so much. Thank you so much.
Thank you so much. That was a very interesting panel, very interesting podium, and of course, we could talk about it for hours. This is not a question, that's true. And as for now, we are almost at the end of our today's journey. But of course, we would like to give you an outlook on the i14y lab. And for that, it's a pleasure for me to welcome on stage Andreas Gladisch and Sławomir Stanczak.
Yeah, great.
All right.
Hello.
Yeah, it was a long day, so we need to do a little bit of improvisation. Sorry about it. Yeah, the question is the future. Seems so. And a lot of people have asked already, so, hey, what's going on with i14y? And what do you want to do in the next years? And yeah, so there are a lot of activities, discussions, etc. And before we share that, because future starts usually in very small steps and not usually. Usually, so there might be some revolutions, but
Almost
it's
surely.
not always good to attend those revolutions, I tell you. that could be very risky and unstable as well. We'll see. So let's assume it starts in small steps, and that's why I would like to share some progress we made the last days in small steps, but it's also a big change in quality and a big improvement for the lab. So I would like to announce 2 new certificates that we can issue now to companies. And first of all, I would like to ask Radisys here on stage. Where are you? Yeah. I got you, please. Please come here. Yeah, and that's somehow also real life of labs. So that's I have to say, because they really did work day and night the last days to find in the lab to achieve all the test cases that are requested by ORAN Alliance. And now we are at the point to hand over the ORAN end-to-end batch because we have achieved that goal. So really great, and it was a pleasure to work with you and to see the ambition and all the engagement. So it's really great, and so let me hand over this badge. So where are the photographs when I need them? Now, second exercise, second end-to-end batch, and I would like to ask SRS to come on stage together with Carsten. Please. And now the funny thing, I hand it over to Carsten, but let me explain first why. So you know, i14y is a joint activity, a collaborative project, and we've split the work between the DT team, more looking at the carrier side, and Carsten's team currently looking more on the enterprise and campus side. And same story, they worked until last night or so to finalize the test with SRS, and that's why I would like to give Carsten the opportunity to hand it over officially. So.
Sure, my pleasure. Thank you very much, Andre, for you and your team's great collaboration. I think it was a well-planned process over the last 2 months. Of course, it always takes longer than expected, but I think the solution really excelled in all the tests that we conducted. So thank you very much, and congratulations.
Thank you. Photo.
Can I say a few words?
Yeah, that was not planned, and
no.
But okay.
I will do it anyway. So first of all, thanks to all the teams at i14y at ENTC and our engineers, obviously. But I just wanted to make one thing, because we are here at discussing Open RAN and open source. We had the panel before, so you know that we are doing open source. The certificate has been, we have put our enterprise solution there to cover the majority of the test cases that are asked for. But this is also good news for open source in general, because like with our open source COD0, it's the same code base, so you're basically getting that trustworthiness that you're getting from ORAN end-to-end test and certification. Today with open source solutions, you know, you can download, you can build it, and you're getting an ORAN end-to-end compliant solution. And I think that is really great, and we are really proud and happy to have worked with you guys. Thank you.
Yeah, so thank you, and usually it's Carsten's part to remind all people that it's not allowed to make advertisements. All right, so now, sorry, Slavomir, for this additional round, but as I said, future starts in small steps. And that's perhaps the right point to reflect about the future. And reflection about future starts with what have we achieved? So, and what is worth to continue, and what is worth to protect, and what is worth even to develop further? Well, a lot of questions. So, looking back, it's the fourth event here. So, what we can do in the lab now, and what all those people contributing to the lab have learned in the last years. How to do the integration, how to do the testing, how to automate the tests, how to run tests efficiently, how to improve test plans, send it back to ORAN lines, all those things. This is from lab testing perspective, I think a big achievement, a big step. And we had a goal to help the ecosystem, the smaller companies, with setting up the test infrastructure. And now we see it works. So first companies are coming. There's startups here in Berlin. Some of you may have seen them at our small exhibition here. So everything grows. Everything goes in the right direction. Yeah, we are not so fast as we hoped to be when we set up the project. That might be also quite normal, but there's an existing momentum. So we also see that operators start to deploy Open RAN. We see that we can help operators, so at least there are requests from other operators globally to get our test plans, to get our test results, to work jointly on new test plans or improved test plans. That everything goes in the right direction. That's my impression. And for sure, there are always ups and downs, so also not a big surprise. And the people who can manage the downs, they might be very successful. So, no, yeah. So that's one point. So another learning, and we now to the last point. It makes a lot of sense to continue this work and to utilize the existing infrastructure and to utilize all this learning. So now the next point. This learning is not only in the lab. So yesterday and the day before, we learned a lot about the question how to work with the academic side. And somehow the i14y was also a role model for that, because HHI and the Technical University, they were a partner from the beginning. And you proposed an emulation framework. So we didn't know that, we call it digital twin that time. But you proposed an emulation framework that we get the ability to test larger environments without having the real environment there. So that was also a starting point at i14y, and we have developed that. It's existing, and it will develop further, for sure. So, and in general, we must think about and use this test infrastructure to improve and make the collaboration between the academic side and the industry side better. So, because this is very unique. But let me hand over to you. We have quite a collection
this
here.
Is diversity. Diversity increases
this
capacity.
Is resilience, diversity, everything.
First of all, it's great to welcome you this year. I think we have you here at HHI for the third time. It was a great pleasure. And yeah, so I think that what you said is right. The most exciting thing about the future is we don't know it. And but we can speculate about the future. So you mentioned digital twins. I mean, it's simple. I think that originally it was about conformity tests, interoperability tests. But then I thought, okay, what about if we want to test, if we have a new component, we would like to test whether the component provides the desired functionalities or not, right? So for this, we need a network, right? I mean, we would have to put the component into a network and look whether, you know, it does what it is supposed to do, right? So, okay, of course, this is not so easy. And then there is this idea of digital twin. It's not my idea. I am not claiming this. But this is what we do. Basically, we had great discussions yesterday and the day before yesterday, including digital twins. There was, for example, one question: what is the difference between digital twin and simulator, right? And I think that, yeah, this question is justified. But I think that AI plays some kind of crucial role in this aspect. I mean, but I don't want to just, you know, continue this discussion here. What I want to emphasize that, of course, digital twins, in my opinion, should be an important part of the whole story in the future. And then there is a lot of AI everywhere. There is some kind of hype. This is what we learned yesterday, and then today, NVIDIA, I think, that also emphasized the crucial role of AI in the future, although NVIDIA is not so good at prediction. I didn't know this. And, here. So, and of course, we need data, right? We need data for AI. To train AI, but also digital twins. I mean, to have a good representation of, say, of a network of physical objects, and good is to be defined and depends on the application. And of course, network operators have data, but there are some constraints related to sharing the data with the academic side. And I think that this problem must be resolved, right? Because I was attending so many panels and people, you know, claim many things, but I think that we have to just, yeah, we need some kind of proof of concept, especially in the context of AI. And for this, we need data.
Yeah.
And one thing I think somebody mentioned, this Open RAN, you mentioned today about this educational aspect. I think that this is something that is extremely important. I would like to emphasize once again. So Open RAN, in addition, you know, to this business stuff and so on, I mean, it's a platform to educate people, right, across industry and academia. I have been working on wireless for more than 20 years, and now with Open RAN we have the possibility to implement things at lower layers, at PHY and MAC. And also network operators, I think that they have the opportunity to influence what is going on lower layers. And then with open interfaces, you can also have access to data at lower layers. So I think that there are some great opportunities, but I think this aspect of educating people, it should be emphasized because it's crucial, right?
Yeah, I cannot agree more. And that was also learning for me the last days, that how important it is to give students, master students, PhD students, academics access to the components of a complex RAN system and to the data.
Yeah.
So, and reflecting about the future role of i14y, of our lab. So I talked already about to maintain and keep the existing test infrastructure, and you're totally right. We must grow in the area of, let's say it more generic, of API testing and testing larger subnetworks at scale, thanks to digital twins, and for those we need data. And there's also a discussion between us concerning the question, how can we manage to make those data accessible for the academic? Because, yeah, you're right, the operators have it, they are not so well trained to share all those data, and there are some good reasons not to share it up to now, but we must fix that. So otherwise, we cannot create somehow a data-based operation if we don't share those data. And we see a role of the future i14y lab for that as well.
Yeah, it's not easy task, I have to say, to share. Maybe, you know, we are not going to share raw data, no? But it's to share some information about the data without violating some kind of privacy policies and things like this, right? So this is a challenge. So you on the one hand, you have to extract or remove some information from the data, and then on the other side, you have to ensure that the data is still useful for applications, right? So there's, of course, trade-off, but let's see. Okay.
Yeah, but this is the point where we stand in the direction how we want to develop i14y further. Surely we talk to potential funding authorities, let's keep it general, and we are not at the point to say, hey, this is exactly this project or that this legal entity, how we want to continue.
That's why small steps, right?
That's why small steps, yeah. And the big steps might be painful, by the way. As well. But that's where we stand. That's the point we wanted to share with you. Hope it's a little bit of an answer for this burning question. I really like that you just asked this question, though, because it seems it indicates that we are on the right direction. And I think at this point, we can somehow finalize and close our summit for today. So
I would say yes.
Yeah.
Everybody is
tired.
Thank
you.
And then please come.
Thank you.
Thank you
come
so much,
join us.
everyone. Yeah, our summit journey is coming to an end, and I would like to thank everyone being here. Of course, the speakers, and especially also you, dear guests. I hope to see you soon and to continue the journey of Open RAN with you, all of you. So, thank you.
So against the plan, I am allowed to add some words.
I mean, Philippe Boschel already told us today you are the father of i14y.
I always try to follow the rules. So what I would like to thank specifically Katja for preparation, all that stuff. Where's Katja? Thank you. So please come on.
Come on stage. Come, Katja.
So. Because that everybody knows, so
without
it's
Katja,
very hard for you.
i14y.
Vielen Dank. That was a lot of because you can imagine how many things you must do in the background and to make these things happen. So
But it's not only me. There's a full team.
Yeah.
And maybe, I don't know who's in the room, but please raise the hand who has worked on making this happen. Where are you? There's Günther, there's Alex who takes picture. Some of the students have already left. Bettina is there. So many people. And we hope you like the you liked the i14y lab and summit. And of course, also the i14y lab. And if you like, there is a chance to give us feedback, very short, you know. We would appreciate that because we only can improve if we get feedback.
Yeah, and the really good thing is, we try to adapt according to the feedback. So as we have done this year with the breakout sessions.
Exactly.
So, but now it's over. Final.
Thank
you all for coming. Thank you.
It's not over. We have the booth crawl.
True.
The booth crawl.
All the marketplaces have organized something as a surprise. So please mingle around, enjoy what they have prepared, and that is the time to have further deep dive conversations, and so use the time, don't run away.
Is a booth crawl something comparable to a pub crawl?
I'm not acquainted with a pub crawl, but I would say we can figure out, and then you can compare afterwards. Is it similar?
It was just a teaser. You know why
Yeah,
I'm
exactly.
and surely the companies can offer beer or so there are no restrictions. If that was the key of your
Andreas,
question.
be careful with saying no restrictions.
All right, so then now.
Thanks a lot.
Thank you. Bye.
Yeah.